Good morning and welcome to the Cutting Edge stage here at CogX 2020. My name is Anushka Sharma. I'm the founder of Naught, and I'm delighted to take you through today's proceedings. The Cutting Edge stage is about tech and technology that's coming down the line in the next 12 to 18 months to really help inform us for our next 5 to 10-year strategy. And that's everything from applications to hardware and software and best use of data. So I'm really delighted to kick off with our first speaker, who is beaming in from New Zealand. So thank you so much to Greg Cross, who is the co-founder and chief business officer of Soul Machines. Greg, welcome to CogX and the Cutting Edge stage.
Cool, thank you. Thank you for having me. It's a real pleasure to be back with you again digitally this year. So yeah, I guess we're gonna get started. I'm Greg. It's exciting to be joining you from New Zealand, and it's actually a big day here in New Zealand. We've just eliminated COVID-19 from New Zealand, and tomorrow we all get to go back to pretty much a normal life here. So I know it's something everybody all around the world will be looking for. So let's get on with my presentation, and hopefully you'll be able to see some of the things that we're up to from the presentation online that I'm about to do. So AJ, can we go to the first slide? Or there we go. So when we first thought about coming to speak about to CogX about some of the work that we're doing with our digital people and with our AGI research, we were going to talk about some of the projects that we're working on and over the last 12 months with customers. And then the COVID-19 era happened, and it changed a lot of what we thought about what was important in the world. It certainly changed our view as to what we could do to make a difference. So we started, as we went into the, early March here in New Zealand, we started asking the question, how can we help? How can we keep people more informed? How can we connect people during these very uncertain times? What are some of the things that our technology could do to inspire the way we all work? But I'm going to start you off by showing you a project that we finished at the end of last year, and hopefully that'll start to introduce my company and some of the work that we're doing. Thanks, AJ.
What up, Mark?
Oh, hey, how are you?
You can see me, right?
Yes.
Yo, what's up? This is Will I Am.
This is the new version of you. We can give him glasses there.
It's pretty awesome. Yeah, I remember I had a pimple on my face that day. You captured it.
The good thing is it's digital and we can remove it really easily.
Well, how come you didn't remove that?
You can make him do a variety of things. Let's play Simon Says. Say, I sound like a girl.
I sound like a girl.
Say that with a higher pitch.
I sound like a girl.
Raise your eyebrows. Poke out your tongue.
Tell me about growing up in Los Angeles.
I was born and raised in Boyle Heights, which is west of East Los Angeles, which is east of Hollywood, just east of downtown. Should it sound exactly like me? Nope. Should it sound a bit robotic? Yes. It should. For my mom. My mom should not be confused.
What's your name?
Mi nombre es Will.
You speak Spanish?
I don't know. I know it needs some fine tuning, but the way it's looking so far is mind-blowing.
So what you saw there was a digital twin that we created of Will I Am from the Black Eyed Peas. We worked with Will during last year, during 2019, and debuted Will and his digital twin on The Age of AI, a documentary series that aired on Google at the end of last year. Last time I looked, it had been seen about 42 million times. So it is really giving us a picture into the way in which we can go about creating hyper-realistic digital people, creating their personality, matching their voice, and then animating them and bringing them to life in real time. And Will jokes away there about whether digital world can speak Spanish. Well, in fact, we can now support over 10 languages in the way in which we bring our digital people to life in real time. So what we're about is, as a company, and this becomes really, really important in terms of the story we have to tell here, is it's about the way in which we can democratize the delivery of incredibly personalized experiences using our lifelike AGI technology. So it's about CGI, it's about what we call autonomous animation, but it's about the way in which we change the experience we can have when we're interacting with machines. So just a bit of background on Soul Machines. We were founded here in Auckland, New Zealand. It's where our research and development is based. Our business is headquartered in San Francisco, where we have a large team of our business organization who is focused on rolling out our technology and engaging with clients in the local market. We refer to our core technology as our autonomous animation platform. We bring our digital people to life using the research that we've done to create a functioning, working digital brain. So it enables us to really focus on how we're going to really take advantage of the opportunity for humans and machines to collaborate as we move forward into the future. And today, our digital people work across a whole wide range of industries and use cases, delivering brand experiences on the model on the digital person on the side of this particular screen is Yumi, who's a brand influencer and works for SK2. And one of the big areas, the big shifts we've all seen as during the COVID-19 era, as education and healthcare have taken enormous steps forward in terms of the use of digital technologies. There's some really, really exciting technologies and differences that we're starting to make in education and healthcare today. And COVID-19 is a great example of what we're achieving here. So when I talk about autonomous animation, I want us all to reflect on what makes us what animates us as human beings in the context of the movie industry. The CGI characters in blockbuster Hollywood movies are animated by capturing actors performing a role using motion capture cameras, and then that data is used to animate the CGI characters. It's pre-recorded content. It's incredibly high quality animation. And what you see that we're looking to achieve as an organization, and you would have seen that in the Will I Am video, is we're looking to achieve this incredibly high quality animation using our digital brain. So our digital people are actually being animated in exactly the same way that we are being animated as human beings. So they will respond, they will interact with us and emotionally engage with us in real time. So the Soul Machine brain is actually driven by a sensory system. They see via the webcam, they hear via the microphone, and they respond in real time to what they see and hear, and allow us to have conversations in a whole range of different use cases for a whole range of different customers and clients. So the digital brain is based around modeling different aspects of the human brain based on neuroscientific research, the concept of a brain stem, and the way in which we breathe, or the way in which the rate at which our heart rate beats when we're, for example, presenting to a big AI conference on the global stage. A limbic system, which is what enables us to engage emotionally with neurotransmitters, and in the case of a digital brain, virtual neurotransmitters, and that the concept of a cortex or a rational brain, which enables us to override our emotional response system if and when we choose to. So some of the things that we've achieved, and to put this into context as to how it works, we refer to our platform as our human operating system. It is cloud-based, it's hosted. Our digital people are hosted in the cloud. They're delivered into our clients' websites and applications as a video stream, in the same way that I'm being delivered to you as a video stream today. So it connects to NLP engines and conversational corpuses in a variety of different languages. So it's very easy for clients to be able to animate and develop new content at scale. A really new feature of our technology, and something we've literally only just released, is Digital DNA Studio, and that is a creative platform so that clients can design and create their own customer experiences and their own brand experiences without us having to be doing a whole bunch of heavy lifting and engineering. So we want to make it incredibly easy for our clients, for our customers, to create and support their own digital people, their own digital teammates, their own digital employees. And then, as we've just been talking about, the patented intellectual property that is our digital brain, which is where we as a company, regard the work we're doing with neuroscience, with developmental psychology, as some of the most interesting and forward-thinking, biologically inspired artificial intelligence. So that brings us, very, very quickly to where we are today. And, we know, in crisis, we are, society, communities, businesses, organizations, it really, really accelerates the need for us to do things differently, to look at how we can do things better. So as I said right at the outset, we pivoted our business. We stopped selling at the beginning of March. It didn't seem like the right thing to be doing, to be going to along to prospective customers and clients saying, would you be interested in buying some of our digital people and implementing the future of customer experience right now? So we stepped back and we started to ask ourselves, well, how can we help? How can we make a difference when the world is starting to shut down? And so, the sorts of things we started to think about were, how do we help meet the demand for information? We didn't know what we didn't know about the virus and how we could catch it, how it spread. So helplines set up by government organizations, NGOs, even large corporations for their employees just couldn't keep up with the demand for information, for knowledge. And then the next thing became, well, how do you keep communications up to the minute? Because literally on a daily basis, new data was being reported, new regulations were being implemented to try and keep people safe, try and stop the spread of the disease. How do we meet the need? So when we're having to communicate during this really uncertain time, how do we meet that need for connection and emotional engagement in the world? So these were some of the things that we started to think about. Call centers, they just got overrun, and no matter how much money organizations threw at their call centers, they just couldn't keep up, and the wait times blew out. So these were the sorts of questions that we started to ask ourselves in terms of, how could we help? And we started off with our existing clients, people who we were already working with on different projects, and we built conversational corpuses based on what was going on here in New Zealand and also in the US based on CDC data. And we went and offered that conversational corpus and our digital people free of charge to our existing clients. Take this information, take this use case and add it to what you're doing, and use it if it can help, if it can make a difference to the messaging that you're trying to communicate and the things that you're trying to achieve at the moment. So after we'd offered that to our existing clients, we kind of thought about, well, why don't we take another step? And we actually launched our own digital person called Bella. So AJ, if you could jump into the next video, please.
Hi, I'm Bella. I was born of the quarantine era to be a Kiwi guide and friend during these uncertain times. But since then I've been constantly learning and becoming more dynamic. I'm here to help. I can share information on many topics including tools for managing mental health and well-being, support for businesses, what the New Zealand alert levels mean, and more. Greg and I are excited to be a part of CogX today, and we hope you enjoy hearing more about my journey and how I can help.
So you've now met Bella. Bella lives at bellahelps.com. So you can go and talk to her yourself. And she was, really designed, initially as a little bit of experiment. So we started off with Bella, really being able to talk about what was going on with COVID-19 in New Zealand on a day-to-day basis. So if you like, she was a frontline responder. She was a digital person, which meant you could get access to her whenever you wanted. You could ask questions about, as New Zealand moved from level 2 to level 3 to full lockdown and level 4, what you could, what you couldn't do. And we were providing that, we were doing those updates literally on a daily basis. So, a lot of work went into just getting Bella up and running and making her incredibly useful as a digital frontline responder. And then as the weeks started to go on and the lockdowns started to kick in here, we started to say, well, that's great. She's, can still answer questions about COVID-19 and the different alert levels, but what else could she do? What other types of content could she work with? How could we make Bella a digital companion that people might come back to on a regular basis to ask different questions about completely different things? So we started to introduce content around mental health and well-being. There's been a lot of discussion about how are people going to feel about being under stay in place or stay at home or lockdown type regimes. There was a lot of debate about mental health and well-being. As an organization, we have psychologists and researchers on our team. So they did a lot of, they brought to life some really interesting applications and use cases in terms of a kindness model. We set up a watch news section for this conversational driven content so that every day people could check back. And Bella started doing interviews with business leaders, with different people in our community, which just was, in some respects a learning experiment, and in other respects an adventure and a journey as we looked at how we might be able to use a digital companion in a whole bunch of different ways. And as we continued on through the lockdown era here in New Zealand, and it started to extend out to many weeks, and the toll started to and people started to understand the impact that this was going to have on different industries, different on the economy, on business. We saw a whole range of organizations that support entrepreneurs, that support small and medium-sized businesses, looking for new ways to provide information about where business owners, business leaders could get different types of help. So, we really also started to form partnerships, which enabled us to bring on more content for different providers and different partners. So, there's a lot of groundbreaking content that has been built here, and Bella, because she is emotionally responsive, she's engaging with people on a face-to-face basis. She's available in an incredibly scalable way. It means Bella was able to provide assistance in a completely different way and in a completely different scale of things. So this was where we started to see some incredible opportunities to do some really, really different things with the content that we were developing for Bella. So some of the key learnings here, and we think these are really, really important learnings as we think about the different crises that we have in our societies and our communications and our organization. Real-time communication becomes incredibly important for us at any time within any organization. So because Bella is cloud-based, she's completely scalable. You can have 10 instances of Bella, you can have 100,000 instances of Bella. She's available 24/7 to connect with people wherever they are. She is connecting because she provides what we refer to as multi-channel communication, not just a voice assistant or a chatbot or a text-based communication system, but a full human to human multi-channel experience where you get the context of all the face-to-face interaction and face-to-face engagements. And then you get into inspiring people about the way in which Bella can be kind, Bella can be supportive as people deal with different issues, different problems, different challenges in this world as we move forward into the future. So the scalability of this solution, in a crisis, and whether it's a pandemic which we're dealing with at the moment, we've seen wildfires in different parts of the world in the last 12 months. We've seen earthquakes, volcanic explosions. There are, no shortage, unfortunately, of times in the world where, we have to find new ways to communicate to efficiently, effectively, economically to large numbers of people at once. And this is not, anything, anything about replacing real people and replacing people's jobs, because we think of this is a way in which we can free up our call center operators to deal with the really, the 10% of the really, really difficult problems that require human creativity and intelligence to really make them work incredibly well. So these are some of the things that we think about in terms of creating scalable solutions and ways in which we can help, not just during the COVID-19 lockdown period, but also, as we, and our local communities and societies and businesses start to re-emerge into the new world. The new world in which we're entering is going to be, extremely different to the way in which we have been in the future. So we've really seen, Bella as a phenomena that has revolutionized the way we think about the delivery of information. We as an organization have learned hugely about the way, a single digital person can have different voices, different purposes, talk about different applications, engage with different communities, and with different people. So, we set out, ultimately to make Bella, a really, really interesting, compelling digital companion for Kiwis. Now, we're, as I said right at the outset, we go back to level 1. It means as of tomorrow morning, social distancing is dropped in New Zealand. So, where we take Bella as we move into the economic recovery period, getting our businesses working together again, reimagining, the way in which industries, the tourism industry, for example, is going to work, and how, starting to think about how Bella, and the way she can deliver information and the way in which she can connect people in these incredibly uncertain times, we think will be, just as incredibly important as she was during the lockdown era, and the area where the primary concern was the health and the safety of our communities and our citizens. So, an example of where this journey has taken us as an organization. We've, Mark, my co-founder, and I have, been incredibly passionate. It's fantastic to work with big companies and big brands and create this future world of highly personalized customer interaction. But we've always imagined that we would be able to make an incredible difference in the world through the delivery of, health services and the delivery of education, for the very, very simple reason that in the world today, we don't train enough doctors. We don't have enough teachers for many communities, and even developed and wealthy countries and communities around the world. So we were incredibly excited that the work that we had started with Bella, got picked up by the World Health Organization, and as recently as last weekend, the Director General of World Health announced a joint project that we're partnering on with AWS to develop Florence, a digital health worker for the World Health Organization. And Florence will be used initially to help dispel some of the myths and some of the fake news that surrounds COVID-19 and has been spread in all types and forms of social media during this era. So this is for us, just one of the first really, really exciting use cases that we've started to see evolve and develop as a result of the work that we've done with Bella through this period of time. We think there are a huge number of opportunities to do some very, very different things with this as we move forward into the future. So I do want to talk about this future now, and we, as we continue to ask that question, in terms of how AI platforms, how AI solutions can help and can make make a difference in a world which is changing dramatically around us, and the variables that we have to think about are a lot less certain than what they were just a few short months ago. So the world is changing. We are having to think about new ways to interact, share information, and engage with each other. Now, this is a challenge, for every single organization on the planet at this point in time. For many businesses today, they're just not able to have a direct personal brand interaction with retail shops, for example, shut all over the world. Enterprise solutions organizations like our own, we're now learning how to sell digitally and via Zoom meetings. How do we establish those personal connections with prospective customers? How are those customers? How do we build relationships and and trust with those organizations as we go forward. So the world as we look forward into the future means, without the the knowledge that there is going to be a vaccine around the corner, means it is an incredibly uncertain world. When we hit crises like this, it accelerates rapidly the way we need to do things and the way in which we need to think about how we can do things differently, how we can deliver different strategies and solutions to enable us to work. We have seen, for example, the dramatic rise in e-commerce transactions over the last 8 weeks. During the last quarter, in most parts of the world, it's more than doubled its previous rate. So e-commerce is now a fundamental part of our day-to-day lives in a way that we hadn't dreamed it would be before. We come from a decade, the last 10 years have been, heavily focused on digital transformation. And, I'd suggest that, what we now think about is we're now in an era which is the digital now area. I can't think of an organization whether, it's generating revenue or providing products and services. I mean, or just government services. Every organization in the world now has to say, how can we be more efficient? How can we protect ourselves against further uncertainty, against further speed bumps or speed wobbles that follow on from this initial shock? How do we digitally enable our business to cope with that uncertainty and that that need to be more efficient? Governments, organizations, which and industries, which we've seen rapid and dramatic digital transformation in a very short space of time, like education and healthcare. How do we continue that on? Because a really, really big and important part of the future is government's income streams are going to be down. The tax take is going to be reduced. Debt levels are higher. Government organizations are going to be under enormous pressure to deliver services, so much more efficiently in the future. So, the world in which we see for the future, the era we've now entered into is, it is really about a race to digital. It is really about a world in which we have to look at, how will we find new ways to deliver services in the world of education. How could we use digital tutors and digital teachers to work with children, in areas where we, maybe we don't have enough teachers. A really interesting project that we've been working on here in New Zealand is looking at how we can protect the native Maori language here, te reo. The government of New Zealand has mandated that Maori language must be taught in all schools, but there is a fundamental challenge here in that there simply are not enough Maori language teachers to put that policy in place in every single school. So, how might we be able to assist that process by providing a digital language tutor? And one of the things you discover once you start working with digital people, people actually really quite, in many instances, prefer to talk to digital people because, digital people don't judge you. We all, will have made an attempt to learn a new language at high school. And if you were like the classes I were in, a handful of people, became fluent speakers of French or German or Spanish really, really quickly, and the rest of us, somehow figured out a way to get a pass mark and get on to the next level. And then that simply happens because in a classroom situation, a lot of students stop putting up their hand and they stop asking the question, Would you repeat that again for me, or I didn't understand? In the world where you have a digital teacher or a digital tutor, they're not going to judge you if you ask the same question or you repeat the same lesson 10 times. So these are some of the amazing opportunities that we see as we move forward into the future. So another really exciting area as we think about digital now is the world of entertainment. All of our entertainers, all of our entertainment industries, Hollywood productions, television productions, our favorite sports franchises and clubs, our favorite musicians, that whole industry has ground to a halt. And who knows when we'll be able to start many of those activities again. So these were already industries in entertainment. They were starting to think about how do we connect ourselves digitally? How do we make ourselves more available and accessible to our fans? And this brings me, I guess, right back to where we started from with digital will.i.am. When we approached Will about creating a digital twin of him, one of the exciting things for Will was to be able to think about and explore how Will as an entrepreneur, how Will as a musician, how Will as somebody who has incredible philanthropic interests in communities in Los Angeles, which are incredibly relevant literally today as we speak. How does Will connect with those people that he's trying to help with those different aspects and different dimensions of his life? So the opportunity for fans to have that incredible one-on-one connection with digital Will and enabling him to amplify his brand and create that incredibly intimate personal experience in a way that is simply not possible for him to do in any other way today. So these are some of the different opportunities that we look at in terms of how can we help, how can we move forward in a rapidly changing world with where we still face incredibly uncertain times, not just from the health risk point of view and the safety of our families and our children and our communities, but also the way in which we are going to shape our industries and the way in which we're going to have to learn to compete in a world that is increasingly digital, in a world where we will be looking for ways to connect our businesses and our brands in a more human-like way, in a more scalable way, and a more economic way into the future. We've learned so much with Bella. We've learned so much about what the potential might be for us and the people we work with during this amazingly challenging time. And I'll leave you with the thought that there is certainly lots to challenge us about the world we live in today. But with all of those challenges, comes the potential, the opportunity to harness the change, to harness the challenge, and to build a better world, to build a better organization, to build a stronger brand, stronger relationships with our customers, with our with the people that make up our community. And that's for us as an organization has been something that we've learned as an incredible lesson, as an incredible platform to take that forward into the future. So I'd like to thank you all for listening to me today. And I think Bella's got a few words to say as we wrap the session up.
Thanks for joining us to learn more about me and Soul Machine's initiatives to help. If you would like to chat more, come say hi at bellahelps.com or get in touch with us via the Soul Machine's website. Hope to see you soon.
Thank you so much, Greg. What an amazing way to kick off the cutting edge stage here at CogX 2020. Bella, the digital Kiwi-born COVID-19 era avatar to really help us through this next steps as we think about how we involve and evolve digital families as part of our digital strategy. So we are going to be back at 12 with our next session here on the cutting edge stage. I am going to be taking you through the program today. We'll be covering a topic called AI, Your Smart Worker. So we'll be back here at 12 and we will see you then. And big thanks again to Greg, wherever you are in the world tuning in from. Raise that cup of tea or coffee and join us and get settled in for the program across CogX today. Thank you. Good afternoon. My name is Anushka Sharma, and I'm here to welcome you back to the Cutting Edge stage on day one of CogX 2020. I'm really delighted to welcome you and introduce our next session. The Cutting Edge stage is here to tell you about tech that's coming up in the next 12 to 18 months, and it's technology that you can use to think about how you're going to be shaping your technical strategy over the next 5 to 10 years. I'm really delighted to be here as your host today, and I encourage you all to join the conversation online using our hashtag CogX 2020. And if you've ever wondered about technology and thinking about how to use AI as a smart co-worker, we're about to hear from Professor David Barber, who is the Professor of Machine Learning at University College London. I'm going to hand over to David now, who's going to be taking over the next session. Thank you.
Good afternoon, everybody. So, yes, my name is David Barber from University College London, and I'd like to chair this session about AI co-workers. Well, this may be something that you've not come across yet, but I think it's a kind of paradigm shift which is happening in industry, and we're likely to see big changes in this area over the next few years. So really, this is about a new approach in which people are able to interact with machines much more naturally, both in terms of training the systems and actually in using them in practice. So to help actually give you some sense of really what's going on currently in machine learning and perhaps what's good and what's bad about it, I'd like to tell you a little bit about a story about a guy called Ben who wants to build a better cat flap. Okay, so this guy Ben here is a very nice YouTube video, and Ben has a cat called Metric, and this cat is very cute, but it often comes home at night carrying prey. And Ben would love to be able to block the cat flap when Metric is carrying prey. So Ben's not an expert in machine learning, but he has an idea that he can use machine learning to block the cat from entering the house when it's got prey in his mouth. So what he does is he hooks up a camera to his door. There's a little window outside with a cat flap door, and the cat is pretty quick. It only takes 2 seconds to run up the ramp. So all the processing will be done on the camera. And actually, the hard part, though, is to make the system so the cat will be blocked, is actually the vision recognition system, the machine learning, the AI component. How do you get the vision system, the camera, to recognize that the cat has got prey in its mouth? So what Ben does is he runs the system over a couple of months, and he collects 20,000 images of the cat on the ramp, sometimes carrying prey, sometimes not. And the key thing here is that Ben hand labels every one of these 20,000 odd images as cat on ramp, cat on the ramp, cat with prey, not with prey, etc. And this is the classical paradigm that people use in machine learning. They've got some problem, and then they get the data all labeled, usually by hand. And then once they've got the labeled data, they'll use that to train an AI system. So one of the great tools then is that Ben can use some machine learning vision system with those 20,000 label examples, and then he can train the system and to detect whether or not the cat's got prey in its mouth. So this is pretty cool. This is really, I think, a great demonstration of the progress that we've made in machine learning, both in terms of the capabilities of these systems, but also in terms of the utility, how easy it is for a sort of a relative non-expert like Ben to actually get a cat recognition system up and trained. And then he tests the system in practice, and it works pretty well. A few hundred times the cat's innocent, there's no prey in his mouth, it's correctly let in, it's just locked out once unfairly. One of the 5 times the cat actually has prey in his mouth, it's blocked 4 of those 5 times. So this is in some sense a very, very useful system. So in a way, this is kind of a good story, but it's a little bit of potentially highlights some of the problems, 2 main problems with AI right now. So one of them is about getting training data. So Ben, it was extremely difficult and time-consuming for Ben to actually label all of those 20,000 images. And this is the typical kind of problem that we have with deep learning. And in industry, you need a lot of labeled data to get your system to be trained quite well. So in this case, Ben actually did all this data labeling himself. It's often common in industry to outsource this data labeling to get people, often in the developing world, to label these images or data points more cheaply. But sometimes that's not possible. Maybe there are reasons around data privacy that you're not able to allow other people outside of your organization to see this data. And there are other issues with that as well. Sometimes it's not possible for non-experts to label the data. So maybe it's a medical image scan and you need a radiologist actually to tell you whether or not this is, say, some kind of lung cancer or not. It's not possible to get, say, Mechanical Turk sort of workers to actually do this labeling for you. So data labeling is expensive and it's very time consuming. It's the biggest bottleneck typically in the machine learning training process. Another thing which is a little bit clunky is that actually often people have much more information about the way that problems could be solved rather than just a binary yes/no answer. So for example, in Ben's case, he could have said, well, maybe the mouth area around the cat's face is a useful area to focus your attention on because that's likely to be where the prey is. So there's much more information that people have about the problem than this clunky approach to just saying yes, no, is the cat got prey in its mouth or not? How can you elicit more naturally the information that people have about a problem? So that's problem number one. Getting data is difficult and it's a huge bottleneck. The other problem or the issue is that the deployment of the AI systems currently is pretty clunky. So the typical paradigm is that you go out there, you collect the label training data set. It's usually very expensive and very difficult to get. Once you've got it, you train the system, and then once that's trained, you just deploy it, and that's it. You don't actually revisit that deployed system typically. So this is not good in situations in which the environment is changing. So for example, in Ben's situation, it might have been that maybe there's a different cat comes into view, also wanting to run at the cat flap, but it's never been seen before. And actually, the system may not know what to do with that. And how do you, ideally, you would like the system to be able to recognize that new situation, and then recognize that it needs some new information from Ben in that case to actually help it to retrain. Similarly, in situations where, say, in your banking loan situation, there's no point maybe using data which is, say, for example, in a pre-COVID situation, because the post-COVID environment were very different to that. So how do you rapidly retrain systems to take advantage of the new situation? So what these things also need is when they're deployed, so if a cat comes up the cat flap, cat ramp, which actually is not recognized by the system, ideally the system will say, well, hang on, I don't know what's going on here. I've never seen the situation before. I'm not confident in my prediction, and actually alert the human to step in at that point and actually prevent the system making an error, but also provide a new training example that the system can use to improve its performance in the future. And finally, another situation which is quite problematic philosophically is that people feel a little bit bad that AI systems are replacing them in the workplace. Actually, a much softer and a much more gentle paradigm would be that the AI systems are really there to help them as like a smart co-worker, to help them solve their problems and do their work more effectively and efficiently. And actually, the human is then allowed to do much more human-like tasks. So, is there a way forward in all of this? So one of the ways forward, and this is where some of the paradigm shift is occurring, is through what's called active learning and deployment. So what would happen in this particular setting is that Ben would have labeled only a few images of the cat. The system would then train, and if it has a certain confidence in its predictions, you can say, well, for the remaining images which have not yet been labeled by Ben, you might say, okay, this image that I'm very confident about, this is clearly a cat with no prey in its mouth. But this other image, I don't really know what's going on here. I'm not very confident. And Ben would be asked by the system to label that particular image only. Then the system would retrain, and this process would repeat, selecting example images that is not very confident in its prediction. And so Ben doesn't have to upfront label all 20,000 images, but there's an active process in which the machine interacts with Ben to understand what the machine actually is capable of doing at any one moment. And this is typically much more efficient in terms of data labeling. You can often get away with an order of magnitude less in terms of training data requirements, and that's very, very effective. And another thing which is very useful is what's called weak learning or weak supervision, in which Ben can provide examples which are more natural. For example, he might say, well, I don't need to provide just yes, no, this is a cat with prey in its mouth or not, but you need to focus, say, on the mouth region or other elements which are instructive for actually how to solve the problem. So how to interact more naturally in terms of providing training data. And it's also very, very important that when these systems are deployed, that they have confidence, they have a confidence in their prediction. So if they say, actually, I'm very confident about this particular case, then that's fine. But if there's a data point or in testing that the machine is not very confident about, that's when the human needs to step in. So this is a very much a sort of, if you like, call to arms for a more AI co-worker kind of approach, where the machine is much more interactive with the human in terms of its training and deployment. So to discuss this, I'm very happy to say we've got three great panelists here. We've got Emine Yilmaz from UCL and Amazon, who's an expert in machine learning and its deployment in industry as well. Ed Chalice from Reinfer, who Reinfer are doing active learning and natural language processing for large organizations, enterprises to help train systems more effectively. And Raza Habib from Human Loop, who have a platform for how to do data labeling more efficiently. So at this point, I'm hoping we can go over to the discussion. Okay, folks, can we move over to the discussion from here? The presentation's finished.
I think we're on now.
Good.
Okay. Great. Thank you. So, thank you, folks. So, if this is so great, all this this kind of idea of interaction, why are we not doing it already? What is the problem? So, Emine, maybe I can start with you. What do you think is the reason people are not currently using this AI coworker idea?
Sure. So there has been some previous work related to active learning, not in terms of AI coworker, more from active learning point of view. I think this notion of AI coworker is relatively new compared to active learning. But there are various reasons why it's not common use at this point. I think one is I believe this idea of AI coworker is even more important than before. So before there wasn't as much focus on it as there is need right now. And I think right now it's about time to think about active learning and this idea of AI coworkers slightly different than it was taught before. I think now it's much more important than ever before because right now one of the major problems is the need for data. Everything is getting more and more automated, but the methods we use are the type of methods that need a lot more data, like deep learning methods. And there has been several examples in the industry where people thought the method is not working very well, like in context of search engines, for example. For many years, people thought deep learning techniques don't work very well and compared to traditional methods. And then people noticed that the reason for that was actually the lack of data. And once enough data is available, these methods can work very well. So I think now people realize the importance of this lack of data and how it could actually put people back or put some of the models back. And at the same time, data has become a lot more valuable because with GDPR and data privacy, people are becoming more and more conscious about like the value of the data, and it's becoming more difficult to get access to some of this data. So I think these are kind of some of the reasons why we didn't make as much progress. And also, I think until recently, some of the models built for like AI coworkers, such as active learning models, they weren't really designed for the models that we use now. Like for deep learning, you need different type of active learning models designed for deep learning, and there aren't that many available. So we need really to design different way of this active learning or AI coworker. I also think that active learning, the way it's designed, needs to be changed. And it has to go more towards like a real AI coworker. I think the model in traditional active learning, the model could only say, okay, I'm uncertain about this example. Can you label it for me? But ideally, it should change now towards a system saying, I'm uncertain about this example because, like in image classification, for example, I can't detect the edges in this one, or I can't detect the nose of the cat, for example. So that the system can ask, okay, I'm having difficulty detecting the nose of the cat. Can you show me more labeled examples related to this? So that you can get examples that are more targeted, for example. So the way we have been thinking about AI needs to change. Active learning and AI coworker is slightly changing, and there is some progress already related to this. Like in this example, you need a model that can identify what it is not able to solve or detect, like what is uncertain about the prediction, for which you need models like that can explain why it's not understanding or solving the problem at hand properly, and ask questions to humans directly in a more human-like manner, not like label this for me, but can you help me with this and which part of it? Just like when a baby learns or when a child learns from a human. I think we are getting there with like work on explainability and interpretability of models, AI, like intelligent assistants asking human-like questions and so on, but there is still more coming there.
Great, thanks, Emily. So let's move to Ed from Reinfer. So Ed, you've been working a while with Reinfer and using things like this. What's been your experience?
Yeah, so I mean, I think this need for active learning is so acute because I personally believe kind of the biggest bottleneck for kind of the promise of machine learning to be realized is the fact that kind of expertise, the people that have expertise about what kind of business problems need to be solved, what kind of properties you want this software to have, are not the people that can create machine learning models and do that whole development life cycle. So just like kind of Excel would have kind of democratized access to making like simple mathematical models, we need a kind of new paradigm of software which democratizes access to machine learning. And in a way, it should be much more powerful than kind of that kind of Excel world, right? Because everyone can say kind of if something's an example of X or example of Y, right? That's not a complex thing. Whereas writing formulas with if statements, I often get stuck in Excel sheets, right? And I spend a lot of my time in kind of computer science and maths, right? So I really think that the kind of the biggest problem we have to solve is how we can get this technology in the hands of experts. So that's business people that understand kind of the business problems they need to solve. And so, yeah, there's the problem around like how you architect these systems. And there's also, I think, a big problem around the kind of UX and UI that you put around this, right? So, I think in the kind of mathematical treatments of active learning, it's often phrased in kind of what's the minimum queries I ask the human. But actually, when a person's interacting with these systems, you want it to be really responsive. You don't want there to be like a 20-minute retraining cycle every time you give it a new piece of information, or God forbid, like a 10-hour kind of retraining cycle. So these things have to be like dynamic and fast, and then they have to kind of display themselves in a nice way. And all of those problems are kind of unsolved, right? We don't really know. There isn't a design language around this stuff yet. And there aren't kind of, in the back end, kind of accepted architectures for how you implement these things. So it's all kind of new territory, but it's absolutely necessary for us to solve these problems for machine learning to be truly useful.
Great, thanks, Ed. So Raza, you're relatively new in the startup, area here with HumanLoop, but what's been your experience so far? I mean, what makes you excited about this as an area?
Yeah, absolutely. I have to say, I really agree with what Ed said, that there's an extent to which machine learning offers this amazing opportunity to scale expert knowledge and for a new paradigm of programming in which instead of sort of, as I said, programming through if statements and things you would have done in Excel or in sort of as a software engineer, actually data becomes the core to this, and you move into a world in which you're almost teaching computers rather than programming them. And to your point of why this hasn't really happened so far, I think there's really two reasons. And one is, I think it's just appropriate tooling and knowledge. So building most of the software that exists around machine learning today doesn't make it easy to implement active learning. There's not good software systems that just allow you to deploy that very straightforwardly. And a lot of people actually don't have that good knowledge about this. In a recent survey, something like 36% of machine learning practitioners, and not even sort of non-experts, didn't know how to deploy these things themselves. And then the other reason is I think it's just a culture thing. Machine learning is almost still stuck in a kind of waterfall era of software design. Sort of you first collect your data, you then annotate it, you then hand it off to a different team of data scientists to do the modeling, and then you hand it off to a different team of people who actually deploy that model. And to make active learning work, to get something that looks more like an AI coworker, what you really need is the ability to actually combine all of these systems into one process. And that's the technology we're trying to build at Human Loop, the ability to annotate data with a human in the loop and deploy that so that even after you've deployed, these systems continue to improve and get new data.
That's great. So, I mean, in all of three of you, to some extent, you touched upon the idea a little bit, the paradigms are important, right? In the sense that if people don't know about this, then they're not going to use it, right? So that we seem to be kind of, as a field, a little bit sort of, not stuck, but we're a little bit, we're inculcated in our ways around this, as you say, or as this idea of, well, you've got your training data, you train the model, and then you deploy it, and that's kind of it, But maybe there's a point here that I think we need to sort of make people aware actually that there are alternative approaches and paradigms available, and people need to actually to be aware of that. So I think I don't know, Ed, maybe you can talk a little bit about this, and when you're going around and you're trying to explain this to people in industry, what's going on, what's been the reaction you've had in general?
Yeah, I think that's a great question. So I think there's the kind of like AI is almost it's in a kind of every newspaper, every kind of news show you listen to or watch. So everyone's aware of these kind of concepts and what the technology can do, maybe slightly overblown. But there is a kind of a real lag between the understanding of what it means to get these things into production, into a kind of commercial organization. And there is a bit of kind of education that is typically needed. If you meet a team that has tried to take a machine learning model to prod, then they're kind of aware of all of these issues, right? And then you come to them with an answer. But if you're talking to someone who's at the beginning of that journey, yeah, you need to actually explain it, that these things aren't as straightforward. You can't just buy a big GPU and hire some machine learning engineers and then hope to get something into production in a reasonable amount of time and have that software maintainable and continuing to provide value. But there are a lot of other components you're kind of missing in that stack. So we definitely, there's a big kind of conversation to be had with a broad kind of section of the market. Those people that are ahead of these things and put them into production, they're kind of really cognizant of some of the pains that you will encounter in that process.
So Emina, you were saying, I think that some of the tools may be not really suited, well to, at least in the deep learning space. I mean, can you explain maybe a little bit more why that's the case? I mean, from a layperson's perspective, it seems, well, it's kind of the concept exists. And what makes it difficult to do this in deep learning?
So in deep learning, usually the models are machine learning models are quite deep in a sense, and it's difficult to infer like what are the effects of different components of the model to the final accuracy, for example, or detect why the uncertainty is caused by the model. And the type of like to reduce model uncertainty or to reduce the need for labels, you really need to develop methods that are suited for this particular case. And for deep learning, because of the complexity of the model, it becomes a little more complicated. there is some work, but very new, and I believe, like David has, you have done some work related to this, but it's very new. I'm not aware of too many related work that could be used to reduce annotation costs specific to deep learning, which is, and now most of the models we use are based on deep learning, so it's a major challenge.
Yeah. So maybe go to Raz. I mean, where do you think the most likely benefit is going to be from using, let's imagine these tools are available eventually, and then where we're going to be using them. I mean, what's the sort of the low hanging fruit, if you like, in terms of the best areas? Is it image recognition? Is it I don't know, natural language processing? Where are we likely to see these systems used?
Yeah, what we've been seeing is sort of as an initial use case, the places where people can get value very quickly are actually places where you have expert knowledge. So we've been seeing things in the legal space and also potentially in the medical space, where you would have potentially doctors needing to understand medical notes or contract review. And these things have been fairly primitive in the past. So there are tools for e-discovery, or there have been tools like Raven or Luminance that allow you to understand contracts more quickly, but they're not as interactive as you might like, and they don't let you then make decisions on top of that information. And so being able to understand these documents very rapidly in a way that's interactive is probably one of the first places where I think this will make a huge difference. And in the last few years, there's been a real step change due to models like transformers and sort of these large language models in what NLP can do. And so we're probably for the first time ever getting to the stage where almost any large company will be able to benefit from natural language understanding.
So, I mean, do you think, and this is a question perhaps for all of you, that, people talk about automation and, it's happening at pace in some areas and less in others. But I mean, is this likely to accelerate? Or, for example, is COVID an example where we're likely to see an acceleration of the use of these kinds of technologies as people realize that actually, maybe these kind of, for example, if the systems change, the data, the whole setting and the environment has changed, like in that banking example, well, where, actually, if you're thinking about giving loans, where the training data is perhaps no longer so relevant as it used to be, is this a kind of area where we're likely to see more activity with things like AI co-workers and active learning come into play, because they actually will help more rapidly retrain systems? Is that likely to be a driver behind adoption of these kinds of technologies?
So I think one of the things you have to think about with most kind of large enterprise businesses which we deal with, right, is there are kind of a number of forces at play which are kind of preventing them from really accessing machine learning and AI, and often that's a kind of slightly behind the curve with the adoption of cloud technologies. So a lot of them are still running a lot of software on premises on their own machines, and that hardware tends to be quite outdated, and it typically doesn't have GPUs, which are absolutely essential for kind of running any kind of modern machine learning stack. And so things like the only reason, obviously this is COVID is a huge impact on the economy, but the only reason kind of all the white collar sector can continue is because of cloud technologies, right? And so COVID is actually a huge accelerant for kind of enterprise businesses' digital transformation, so moving things to more digital kind of online tools and technologies. So that's a huge forcing function. And I do think that things like COVID underscore how much businesses need agility, how much they can change the property of a software system, and how long that takes. And without something like active learning, you just can't do that. And when I became aware of COVID, I started to call up all our customers and just see how they were doing. And a lot of them already used Reinfer to create kind of models bespoke to COVID, because they have international operations and they have teams in China and Southeast Asia, and they were already using the tool to understand and monitor and automate that stuff. So you absolutely need to, agility is so important with software and flexibility. And I think any kind of shock just underscores that,
Yeah, so maybe I can switch to a slightly more philosophical point now, which is that this all sounds great, the idea of systems which are interacting with people and helping them. But I could also sense maybe there's some unease about that, is how do people feel about a system which is potentially, now interacting with them? Is that going to be a little bit problematic in some sort of ethical sense? Are people going to be more nervous about, well, the machine's asking me, more and more about my own personal abilities and my feelings about, this particular problem? That seems to be, is that a potential clash there? I mean, are people likely to feel comfortable with this kind of more interactive AI machine approach, or is it something that is likely to be, well, that's not, we don't want to go there. It's not really appropriate. Emily, maybe you have some experience around that a little bit.
Sure. I think we have to be careful that users do feel comfortable about working with AI. Like, for example, in some cases, when the users feel that AI is monitoring them, that is indeed a potentially uncomfortable feeling. But AI doesn't necessarily need to monitor all the activities of the user. They only need certain aspects that are related to the particular task AI is kind of trying to help the human with. So that's why privacy, differential privacy, and so on, techniques like this are becoming more important. Also, in many cases, it's not that particular individual that the AI is looking for. It's more aggregate over behavior of many individuals, aggregate behavior across them that the AI needs. So it's not like an information about particular individual. I think we have to make sure that people are aware that they are not really monitored, and we have to be careful when we design AI so that the techniques that are used are designed in such a way. And that's why I think this intelligent coworker and active learning and so on, it comes hand in hand with work on privacy and differential privacy. So in the next few years, we definitely need more advancement in these fields as well.
Yeah, so Rosla, go ahead.
Let me add to that, David, as well. One of the things that I'm really personally excited about this new paradigm is not that we should watch people and monitor what they do and sort of try and replace it, but actually that by giving people the ability to program computers by example, by teaching, you actually allow people to have a lot more control over what the AI and software can do than was maybe previously possible in these black box deployments. And there used to be this metaphor that one day computers would be like bicycles for the mind, something that would augment our abilities rather than replace them. And I feel the active learning paradigm, this ability of like teaching the computer to help you, actually offers that possibility. So it's not a question of being monitored. It's a question of working collaboratively with the system.
Yeah, I totally agree. But also, there were people whose job it was to do, simple kind of arithmetic and calculations. I think, people actually had like the job title to be a calculator or something, so
computers that.
Yeah, exactly. So I mean, these things will change the nature of work and will change the roles that people have, but I believe they will give people kind of superpowers to do more. But so I think on the micro scale, everyone likes having good tools and being enabled. On a macro scale, I think societies have a responsibility to think about the changes to the job market and how to kind of give people the safety net that's necessary. I mean, these things will create, I think, a huge change to our society and the way that people work. So there's definitely not kind of naive questions. I think it's really important that societies start to think about how we're going to deal with this new technology.
So also, I mean, in some sense, I can see very positive aspects of this in the sense that there are, you can free up people to do more human-like tasks, which is great. But also, it seems like maybe on the negative side, is that well, actually, that organization which is now potentially using I helped train the software tool through my expertise in that organization. I've told it the answers and in certain cases, and I've actually told it how to solve certain tasks. So to some extent, it's good because you can now if you like, scale up across your organization the expertise of an individual, which sounds great. But what happens when that individual leaves the organization? Are they now, do they feel that they've, left some of their own intellectual property, if you like, behind the organization, or are they going to feel bad about that? How's that going to pan out in the future?
Well, I would bring a couple of things to that, right? Firstly, I don't think that you're ever going to be able to capture the entirety of an expert's knowledge. So the things that we're teaching the computers to do are really a small piece of what that person does. But also, I would say just look at the alternative, right? Which is that you have a small number of really key employees who, if they leave, they take years of knowledge and experience with them. And actually, this is a chance for them to leave something behind for the rest of their team to continue benefiting from their work, not just when they're there every second, but even when they're not available. As you said, to scale them across an organization.
Ed.
I mean, David, I mean, you're professors, right? I mean, you've dedicated your life to self-replicating your knowledge and expertise, so I mean, I think machine learning is still in this kind of age of kind of interpolation. So, we can kind of teach machines to do these kind of tasks, but they're a long way off from solving the more complex things that most employees are engaged with at work, right? So this is really about kind of scaling an expertise and making experts more powerful and productive rather than replacing. We're some way off from replacing.
I believe there are two types of work that an employee does. One is this repetitive tasks that are probably going to be replaced with AI, and the other part is this more creative tasks that definitely require human input. And when we have AI systems as a co-worker, these repetitive tasks, the AI system will stay. It's like the expertise, even if the human leaves, the expertise of that, it stays. It's the more creative part that might leave, like the expertise related to that when an employee leaves. But then it's really the core part that needs to be transferred to the next employee, for example. So I think it might be even helpful in like this like employees moving around in terms of knowledge transfer, because the repetitive part stays with AI and AI stays with the company.
Well, this sounds all very kind of futuristic almost. I mean, where are we really? I mean, do we have anything like these kind of tools right now? I mean, are we talking about 5 years, 10 years from now that we're really going to be able to have tools that we can very, very comfortably interact with, or is that much more? Is the horizon much shorter before we're going to get hold of these things?
I think the horizon's much shorter. I mean, I would say that Reinfer has all of the properties of these kind of systems that you're describing, and we're going to see these same kind of patterns of interaction with these intelligent co-workers emerge for different business problems, different kind of types of data. This stuff is very it's new, and it's being kind of developed by loads of different companies and loads of different sectors. But it's still very new, I think it's just working its way out through the market.
Yeah, I completely agree with Ed. I think the time horizon for what we've discussed is much shorter than that, right? And there are some particularly innovative companies like Reinfer that already have this in the market. The largest sort of tech giants have been doing things like this for a while. I mean, what we're trying to do at Human Loop is give the tools to most companies to be able to start building those things and have systems like that themselves. But it'll take time for that to percolate across. But the most tech-forward people already have this.
Yep.
So why don't we see it? I mean, why are they not deploying that right?
I mean, if you work at Facebook or Amazon or Google or you'll probably Facebook probably has 30,000 people. I'm just made the number up, right? But people doing moderation with active learning AI systems. I would imagine Amazon has the same thing in product categorization. Google has the same thing across content moderation and hundreds of other kind of applications. So these tech giants internally will have this tooling, right? It might not be a very nice, it might not be very aesthetic. Maybe it is, but all of the tech giants have been working on this stuff for years, and what we're starting to see is that being made available and sold and commercialized and packaged up.
Yeah, although I would say, Ed, my experience, at least sort of having worked in some of those places, is they have it in a kind of patchy way. So it's not like this is done
productized, yeah.
And I think part of the reason for that is kind of what we said before about there's a kind of culture shift, right? Often the people responsible for data collection and annotation are separated from the people who are doing the model building. They're not necessarily the same teams, and there's often handoffs. And making active learning systems work in that kind of cultural environment can be quite tricky. I think you need tools that sort of reduce the barriers for this before it will be widely adopted. But the technology definitely exists. It's a question of productizing it and bringing it to market.
Yeah, I mean, some of the mathematical sort of like, I think M&A was touching on this as well, that it's not so straightforward to do some of this. There are tools which are available, but getting good uncertainty estimates out of these deep learning systems is not so straightforward. The better the estimate of uncertainty is, then the more useful it is. I mean, it's a little bit like you can imagine if you had a real person as a co-worker and they were very confident, all the time in their predictions, but they were maybe a little bit arrogant in their predictions. And, sometimes they get it right, but sometimes they're very confident. Oh, they say, believe me, this is
They just get promoted, David. They just go straight to the top.
Maybe, but I think people are very sensitive to errors. When people are very arrogant, right? Say, well, this is definitely the right thing to do, and if they get it wrong, right? Then people are very, very sensitive to co-workers who are arrogant and not aware of their own limitations. And I think that's a similar issue a little bit with these deep learning systems. They're so complicated. Actually, as M&A was alluding to, actually trying to understand, the uncertainties that these systems actually have in their performances and their predictions is not so straightforward.
Yeah.
But I think there are, in my experience, tools which are coming on stream from the research community, I think, which we're seeing which can help in these situations and certainly come up with reasonable estimates of uncertainty in these deep learning systems. And I think whilst conceptually this is not necessarily new, computationally it's still quite fresh. And I think, as we were saying before, it takes a while for these kinds of tools to percolate from the academic environment through to the actual tooling that you might see in industry. And I think that's I'm hoping that will happen in the next year or two. So maybe just to in 30 seconds, starting from M&A, would you just like to sum up any take-home thoughts that people should have?
I think it's the time that, as you mentioned, some of these models, I think the need for like AI coworker, active learning, more embedded into the type of models we use is obvious, and there will be breakthroughs or more work related to that. I think the way we see AI as a coworker will also probably change, though. For example, in this example, like cat predictor, wouldn't it be cool if AI itself kind of predicted or noticed that Ben needed a cat predictor, and then looked at Ben's behavior, and AI learned how to build a cat predictor itself. I think that's the direction we are headed towards. Instead of us specifically training AI for certain tasks, AI learning from us, and then not needing as much feedback or labels from the humans. So the interaction becomes more and more natural. And so that would be kind of more like going towards this AI as a co-worker and more natural interaction between humans and AI. And I think that's what's coming up in the next few years. And companies like Reinfer and Human Loop, I believe they are headed in that direction. So there is work related to that in the industry as well.
Great. Ed?
Yeah, I think to any kind of business people out there thinking about employing this technology, I think you need to think about these things, right? So ask questions of any kind of technology or proposition. How long does it take to train? How do I update the model if I want to kind of correct it or add some new kind of feature to it? How do I maintain it? How do my kind of experts interact with it? That kind of the life cycle of a model and how it's controlled is so important if you're going to kind of realize the business benefits, and you need to have those kind of intelligent conversations to kind of realize them.
Great, thanks. Raza?
Yeah, I would say that again, if I was a business person or someone who's not a machine learning expert thinking about using these technologies, what I would say is don't think about machine learning as just another tool in the software arsenal, because it really is something that's quite different. It represents a different way of programming computers, where really the data you use becomes the core. If I gave you the source code to the Google translation system, it wouldn't help you. It's the data that really matters. And so having a new suite of tools, the right tooling for getting the data, annotating it, curating it, building and deploying models in such a way that they continue to improve and you can understand that data over time is really a different way of approaching things. And so sort of making sure you take a data first mindset is what I'd sort of take away.
Great. Well, then thanks everybody. It was a great session. Raza, M&A, and Ed. And yeah, see you next time. Bye.
Thanks.
Thank you.
Gosh, thank you so much. Thank you, David, to M&A, Raza, Edward, and David Barber there from UCL. Thank you so much. We have learned so much about AI as a smart co-worker. I don't know about you, but as someone who is an expert in a limited field, I think understanding the cognitive pressures and taking that off so I might be able to focus on a different area of the work I do in the creative way. This is a really interesting proposition. And remember, if you have any questions for David and the team, you can link through on Slido. There is a Q&A session, which is going to be kicking off at 1 o'clock for half an hour. And so if you have the right ticket there, you'll be able to proceed through to the Q&A session. This is the cutting edge stage. This is day one of CogX 2020. My name is Anushka. I'm your host, taking you through all of our proceedings today. We'll be back at 2 p.m. on our next subject, which is exploring the interplay between artificial intelligence and collective intelligence. I hope you'll join me for the next session. Make sure that you're joining the conversation, using the app, networking with your fellow virtual attendees, and join the conversation using hashtag CogX 2020. I'm Anushka. I'll be back at 2 p.m. to welcome you here on the Cutting Edge stage. Thank you. Good afternoon and welcome back to the Cutting Edge stage on day one of CogX 2020. My name is Anushka Sharma. I'm the founder of Naught and I'm here to take you through today's proceedings. Make sure that you join the conversation online with us with the hashtag CogX 2020. Let your friends know about what you're learning here. The Cutting Edge stage is the place where we're looking at technology that technologists and academics and entrepreneurs and institutions are leading on over the next 12 to 18 months. And it's really to allow you as attendees to understand where that might fit into your strategy over the next 5 to 10 years. So I'm really delighted to introduce the next session, which is exploring the interplay between artificial intelligence and collective intelligence. I'm going to hand over to our host for the next session. It's Ravi Gurumurthy, who's the Chief Executive of Nesta. Over to you, Ravi.
Thank you very much, Anushka. As Anushka said, today's session is really focusing on the interplay between artificial intelligence and collective intelligence, how humans work together in teams. And when you think about the different narratives about AI, they often paint AI either as a savior that's going to do heroic things that we could never possibly dream of, or as a villain that's going to destroy jobs and human input. We also think of AI also as a given, technology that's going to just happen to us rather than a technology that we can shape for the good. So today what we're going to do is explore alternative future visions of AI, focus instead on how technology can help make the best use of collective human intelligence to address social challenges, whether that's dealing with COVID or healthcare or agriculture or even human rights. And with us today to talk about these things, we have four fantastic speakers and participants. First of all, from my own organization, Nesta, Dr. Alex Bedchevskaya, who is the researcher on AI and collective intelligence at Nesta's Center for Collective Intelligence Design. We also have Yvonne McDermott-Rees, who's a professor of law at the Hillary Rodham Clinton School of Law at Swansea University. And her expertise is in the law of evidence, international criminal law, and human rights law. And we have Dr. Durrani Darbura, who's a data scientist with Pulse Lab, who's joining us from Jakarta. And that Pulse Lab is a data innovation facility between the government of Indonesia and the United Nations Global Pulse Program. And he's responsible for managing projects related to digital agri-food systems. And then finally, we have Dr. Louis Rosenberg, who is the CEO and chief scientist of Unanimous AI, a Californian company focused on amplifying human intelligence using AI algorithms modeled on natural swarms. So with that, I'm going to hand over to Alex, who is going to talk a little bit about how AI is already helping to enhance and scale collective intelligence.
Thanks, Ravi. I'm going to assume that you can see my slides and go ahead and get started. So I'm starting by talking about a company that maybe some of you have heard of. It's called Blue Dot, and it was one of the first to identify the emerging risk from COVID-19 in December. It's one of a host of AI systems that help to identify signal in the noise of unstructured human collective intelligence. It uses natural language processing and machine learning in order to parse through diffuse, distributed human contributions, such as news reports or notices from expert networks like ProMed and WHO, and combines this with novel data sources like airline traffic data in order to generate an early warning to its clients about the spread of infectious disease. And of course, in these contexts, timing is everything. So that's not the only part of the story, though. We're also really interested in what happens after that early warning signal. So it's really important to think about the interpretation of those signals. And that's where networks of experts such as policymakers, infectious disease experts, medical professionals, and even citizens come in to help us respond and manage an emergency. And it's this active collective intelligence that's also a very important part of the puzzle when dealing with big global problems. And so today's session is really going to focus on how we can make the most of both human and machine intelligence in order to address challenges. But what exactly is collective intelligence? It's an old idea. It's been around for a long time, and traditionally it refers to how people think and act together in groups to solve tasks or problems. And what emerges is often more than the sum of its parts. So one of my favorite examples is the crowdsourcing of the first edition of the Oxford English Dictionary, which took over 70 years in total to collect 415,000 words. And it sounds funny because now when we think of a modern equivalent such as Wikipedia, there are more than 6 million pages created each month. And of course, the difference is that with 21st century collective intelligence, we have digital technologies that are allowing us to connect ideas and insights from people with novel data sources at a scale and speed that has never been possible before. And so we've seen the proliferation of methods that take advantage of these distributed inputs, those that aggregate and combine independent contributions from many people, such as crowd predictions, and even those that are more interdependent and depend on deliberative processes or problem solving in real time, such as decision making platforms for digital democracy or peer learning networks. And AI is a vital part of the toolbox that's helping us to turbocharge collective intelligence. And when it comes to solving complex problems, it's really important that we have both human and machine intelligence because they bring different strengths and weaknesses to the table. So human intelligence is very flexible and it allows us to apply contextual judgment. On the other hand, AI is incredibly consistent and manages to process vast amounts of information at incredible speed. But it gets stuck in its ways, which means that when there's a dynamically shifting global problem, which is often the case in complex problems, then it struggles to adapt. And that's why we need to figure out what are the complementary mixes of both human and machine intelligence if we want to address different parts of these bigger problems. That's exactly what our research at the Center for Collective Intelligence Design is concerned with. How can we design systems that make the most of both human and collective human and machine intelligence? We published a report earlier this year, which was an analysis of existing case studies that looked at collective intelligence methods ranging from crowd mapping to citizen science, and saw how AI was already being used in their context and having techniques such as natural language processing or computer vision and autonomous systems applied in those contexts. So the first type of interaction that we found, and there are 4 in total, but of course this is a kind of emerging framework, was like the early warning systems that I described at the beginning. So it's where we have AI help us to make sense of and give structure to distributed, passively generated human knowledge and other data sources. In the second type of interaction, we have distributed microtasking performed by a crowd on a particular task. And we saw examples of AI being deployed alongside the crowds in order to perform the same tasks. And in these contexts, it was interesting because there was often a feedback mechanism, which meant that over time, the crowd could monitor and continuously improve the performance of the AI algorithm. The third type of interaction is the most elusive at the moment in the real world. So it's all about how AI agents can form part of a closed loop system with groups of people in order to make decisions and predictions in real time. And we'll hear about one of these examples from one of our speakers. And then finally, the fourth type of interaction we mapped was all about applying AI behind the scenes. So how to optimize processes within collective intelligence in order to enable better matching of information to people or helping people, for example, in digital democracy platforms to find each other if they have similar interests so that they could join together and collaborate to achieve more. Normally at this stage in my talk, I would go to describe a couple of examples in the real world, but I'm going to defer to our other speakers who are going to be actually giving examples of their projects later after I finish. So to go on, you can also explore many other case studies that we've published online. But I'm going to continue about other strands of our research, which are actually looking at how collective intelligence methods can improve the technology that we're developing with AI. We've heard over recent years a lot of concern about historical biases and also structural inequality that's being hard-coded into algorithms. And this is a really important issue to pay attention to. The Gender Shades project on the slide is one that was led by Joy Buolamwini that helped to highlight how facial recognition systems are far less accurate for certain demographic groups, specifically women of color. And it's work like this and other incredible projects that are helping us to realize how these systems are limited and who they're actually benefiting and who is being left out, whether they're not being represented in data sets or they're absent from them entirely. But collective intelligence can help because at the principles of successful collective intelligence design, at the core of it is the need to involve a diversity of contributions and also to ensure that benefits are spread amongst those who are contributing to a project. And when we think about the AI lifecycle or the data pipeline, there are many different intervention points at which these principles can be integrated in order to improve the technology. It's not just about having more diverse data sets, but it's about involving more opinions and voices at every stage, from the planning to the monitoring and the use of these systems in the real world. And so we can start to see that AI and collective intelligence are very interwoven and mutually dependent. And that's why it's really important with these systems to really pay attention to questions of design to make sure they're as good as they can and should be. And in the report, we talk about a number of tensions that innovators might face when trying out these methods in the real world. And of course, it's not as simple as binary trade-offs. And I'm not going to have a chance to go into the details of everything on the slide now, but I hope we can start to get into these during the panel discussion. As part of our research at the center, we're also exploring what the future might look like if we start to see more examples of AI and collective intelligence. And today we published a series of stories that look at implementing these systems to improve our healthcare or to address issues of misinformation or enhance creativity. And you can find them on the Nesta website. We're also really interested in building a community of practice around this. So we support practitioners to carry out experiments that test out these ideas in the real world to make sure that we are making the most optimal design choices. And I'm going to now hand over to some of those incredible grantees and our other speaker as well from Pulse Lab, who are going to talk you through what it looks like when you have collective intelligence and AI combined in the real world. So first of all, you're going to hear from Louis Rosenberg, who is going to tell us about the technology that Unanimous AI has developed, Swarm AI.
Hi, I'm Louis Rosenberg, a CEO of Unanimous AI. And over the last 5 years, we've developed a very different approach to AI called Swarm AI. And rather than using AI to replace human intelligence, we use AI to connect groups of people together into real-time systems modeled after natural swarms. And in scientific terms, we turn human groups connected over the internet into a swarm intelligence that can be significantly smarter than the individuals could be alone. So why swarms? It turns out that Mother Nature, through the process of evolution, has spent hundreds of millions of years working on this problem of collective intelligence. And this has been for social species that make decisions together in large groups. For example, flocks of birds, schools of fish, swarms of bees. Now, in these species, you have large groups. Each individual has a slightly different view of the world, different past experiences, even different temperaments. So how does nature harness and combine all of these views to make optimal decisions? Well, what nature does not do is nature does not take votes, conduct polls, run surveys. There's no SurveyMonkey in nature. Nature also doesn't do post-processing on big data sets. There's no big data and machine learning in nature. What nature does instead is form systems, real-time systems where the groups push and pull on each other with feedback loops and converge on optimal solutions together. And that's what's called swarm intelligence. And so the question that inspired us to found Unanimous AI was simply this: if birds and bees and fish can get so much smarter by thinking together in swarms, why can't people do it? And it turns out that we can, if we connect people together into systems. So what you see here on the screen is an artificial swarm. It's about 100 people connected together over the internet in real time, moderated by AI algorithms, and optimized for making forecasts and decisions. And what we've shown over the last 6 years or 5 years through lots of different studies is that it works, that human groups can get significantly smarter. So for example, last year we published a study with Stanford University showing that swarms of medical doctors, when connected together into swarms, could increase their diagnostic accuracy by over 30%. We also published a study last year with MIT showing that swarms of financial traders, when connected together in real time, could increase their forecasting accuracy by over 25%. And we have a new study that we recently did with Nesta showing that groups of voters with conflicting political views could prioritize objectives significantly more effectively as a swarm than by taking majority vote. So in short, we found the best way to amplify the collective intelligence of a human group isn't by aggregating the data, but by connecting groups of people together into a unified intelligence. And that is swarm AI.
Thanks, Lewis. And now we're going to hear from Yvonne McDermott-Rees, who'll be telling us about how collective intelligence and AI can be combined for human rights.
Thanks, Alex. Thanks, everyone. Well, as people might be aware already, when war crimes and other serious mass human rights violations have happened in recent years, eyewitnesses are increasingly picking up their mobile phones and using them to record videos and images of these atrocities taking place. And our Nesta-funded project sought to examine what steps need to be put in place to ensure that this citizen evidence can be used to support legal accountability processes. There are a couple of challenges in this regard. The first is the volume of this kind of evidence and how to store and manage it. So in our experiment, we developed a new system. You can see in the bottom left-hand corner a screenshot of it in action for managing collections of open source and confidential evidence. So we developed a tool to preserve open source evidence in a way that will meet the chain of custody requirements that courts have. And then we integrated that tool with Uwazi, which is an evidence management software, to mean that evidence can be curated and organized with tags for evidence of the same incident. The second challenge is finding relevant evidence. So in our case, we wanted to search the entire archive of YouTube videos from the war in Yemen to find specific examples of cluster munitions, which are illegal. And our experiment partners in Yemeni archive developed a machine learning algorithm to detect cluster munitions in videos. You can see them in the slide in the top right-hand corner. This was actually really challenging because there wasn't a good pre-existing collection of videos to act as a ground truth sample. So we had to create our own using synthetic 3D imagery. You can see in the bottom corner there, the 3D imagery in action. And our experiment demonstrated how machine learning can assist human rights investigators in filtering these massive quantities of user-generated evidence to detect the most relevant photos or videos to their case. And we think these methods could be used in other contexts for journalism, history, academic research, to find the best evidence from open sources. Our experiment also uncovered some of the barriers to collective intelligence in human rights, and these include concern around the security of the data and its admissibility in court. So by creating a secure, integrated evidence management system to include both open source and closed data, we were able to demonstrate how mixed masses of evidence can be taken together to prove the existence of mass human rights violations. As a result of this experiment, our project partners, GLAN, the Global Legal Action Network, were able to submit a dossier to the UK government showing how arms sold from the UK were used to carry out unlawful attacks in Yemen. And this project enabled us to combine this citizen evidence, collective intelligence and action, with evidence gathered locally from field investigators to draw insights on war crimes. So, we really look forward to hearing any questions you have about the project. Thank you.
Thanks a lot, Yvonne. And so finally, we'll hear from Dharani Darbura from Pulse Lab Jakarta, who'll talk about their mixed methods approach to development.
Hey there, hello everyone from Jakarta. I'm Dharani, I'm a data scientist with Pulse Lab Jakarta. Firstly, thank you very much for the organizers for giving the lab an opportunity to present itself on this platform. Pulse Lab Jakarta is a data science, data innovation facility that is co-owned by the government of Indonesia and the United Nations Development Program. Our mandate is to use a combination of data science approaches and human-centered design principles to assist national and international governments to build data solutions across for challenges across those theme areas. My role in the lab is to improve the interpretability of machine learning and artificial intelligence approaches. I mean, highly complex machine learning AI approaches are kind of work like a black box. And my role is to, and we have started to realize that it's not, just machine learning and AI approaches cannot be the solution for everything, and that's where we are starting to rely on human intelligence combined with data science principles. I'll give an example of one particular project called, in the field of agriculture, where we wanted to use a combination of multiple big data sources, from high-resolution satellite imagery to even administrative data, that is the census, to identify farming communities that have been consistently producing consistently faring very well across time. In any community, there are certain individuals who do better than the others. Right, and this approach of positive deviance, which is called positive deviance, where the people who do better are called deviants. In the traditional way of positive deviance approach, it would entail, participatory approach where someone where someone actually goes, a demographer goes into the community, looks at the community, understands who these individuals are, and then tries to understand the reason for deviance. Our hypothesis was that since we've got access to big data, which is in terms of like remote sensing and satellite imagery, it would be easier to identify these deviants, which is a very cumbersome process in the old positive deviance approach. Turns out that's not the case. Actually, we had to rely on human intelligence at every level, everything from defining what success is to understanding how do you define communities, to understand what are the measurement parameters, to even validate our findings. So so I'm happy to share a little more about this work in the panel discussion, and I'm really glad that I'm able to represent the lab on this platform. Thanks.
Thanks a lot. So now I'll hand over to Ravi, who will be moderating our discussion.
Thank you very much for those fantastic examples. When you look across them, in some cases, it's really very clear where the complementarity exists between humans and artificial intelligence. So in the example of Yemen, it's obvious that you cannot do what you're doing, Yvonne, in relation to prosecuting human rights violations without the raw human input that is then captured and synthesized. But in some other examples, like the radiology example, I think that Lewis can talk about, it's not clear to me where the complementarity sits between humans and machines, or how that is changing, and whether we're just in a temporary moment where humans and machines together are better, that may well actually be superseded by a moment where actually pure AI on its own is actually a better option. So, Lewis, could you perhaps comment on that? And I'll ask one or two others to comment on it as well.
Sure. So certainly in the field of radiology, there's been a lot of progress with straight artificial intelligence, with deep learning that can process large numbers of X-rays and then make accurate diagnoses. And in fact, it's the progress in the field of radiology has been so significant that radiologists are scared. They're scared about losing their jobs, losing their profession, because it looks like machine learning could just replace the entire field. And that actually was the inspiration for us to do an NSF-funded research project with Stanford University Medical School to say, hey, what happens if we take groups of doctors and connect them together into swarms? Can they take the title back for humans to be the most accurate forecasters? And what we found was that when you connect groups of people together, and these were small groups of radiologists, just 4 or 5 radiologists connected together by AI, they were able to match and even exceed the deep learning systems. And so that was interesting. But what was most interesting was that we discovered that the AI and the humans had different strengths, very different strengths. And so the AI was really, really good at making rapid, accurate diagnoses of cases that it had seen before, things that were similar, but really failed when it saw something unusual. Whereas the humans were really good at diagnosing things it had never seen before. The humans were able to basically extrapolate from their years and years of wisdom and experience and knowledge and training and see something totally new and make a more accurate diagnosis. And so ultimately what we found was that if we combined these two strengths, if we allowed the AI to diagnose cases that were very, very similar to things seen in the past, but allowed these human groups moderated by AI to diagnose cases that were unusual, the combination was more accurate, significantly more accurate than either by itself.
And Lewis, one of the things that you said interested me, which is that when it comes to diverse perspectives, swarm intelligence is very, very good at combining those diverse perspectives into something meaningful. And although we often say that diversity is good, diversity produces better results, I think as humans, we often struggle to actually synthesize and get the best out of the rich perspectives we have available to us. Can you just say a little bit more about how swarm AI really enables diversity and the full potential of it to be realized?
Yeah, so, and again, it goes back to nature. In the natural world, the only reason why swarms evolved was because you have these large populations of individuals that all have slightly different views of the world and have slightly different experiences and slightly different temperaments. If they all had the exact same knowledge and experience, you could just ask one of them and get the best decision. And so diversity is essentially the requirement for swarm intelligence. And what we found is that when we do that with human groups, especially groups that have diverse either backgrounds or experience or expertise, and we combine them with AI, the end result becomes significantly more accurate. And I can go back to a medical example. If you take a group of doctors who are, for example, doing treatment planning, and maybe that group of doctors is very diverse. It has an oncologist, it has a radiologist, it has an internist, it has a group of people who all have different backgrounds, different perspectives, they come at the problem differently. In a traditional setting, they'd sit around a room, maybe argue about it, and come up with a decision, and that decision might be influenced by politics, decision might be influenced by hierarchy. When we bring groups together as a swarm intelligence, there is no politics, there is no hierarchy, everybody's equal. And what we're doing is we're basically looking at their different levels of confidence and conviction and combining their insights to give the strongest possible combination of their views. And it turns out that it works. When we do that with diverse groups, whether it's medical, whether it's political, whether it's financial, we see groups converging on decisions that are significantly more accurate or significantly better representation of the population than traditional methods.
Just turning to Alex, this question about how you combine human and machine intelligence. COVID is a good example where you've got lots of different perspectives coming together in a room to try to make recommendations. Can you just say a little bit about the limits of AI in relation to COVID, but also the value of human and machine interaction?
Yeah, of course. So I guess it picks up a little bit on what Lewis has just been saying. It's been really interesting to follow the reports in the last couple of weeks and months about the failures of AI that are being exposed as a result of changes in behavior that have come on in response to COVID. So we see recommendation systems on platforms that are suddenly getting an influx of new subscribers who perhaps have different viewing patterns than the ones that they've been trained on, failing and becoming a lot less accurate, or their performance suffering from the kind of changes in the distribution of inputs. And we also see that there's inventory kind of changes and fraud detection mechanisms, which are really struggling to adapt in this dynamic situation. On the other hand, when it comes to some of the most successful responses, such as the mutual aid networks or the kind of DIY maker approaches, they are built on existing communities of innovators, which have been built over time for people who come together to work on a particular goal and who have a shared kind of discourse and understanding and shared tools to work on problems together. I mean, a great example of that is how we're seeing research being transformed over the last couple of months, and how many researchers have pivoted to try and apply their expertise in order to address questions of biology, but also questions of mental health and supply, and developing new solutions to actual treatments of COVID, and how introducing practices of open repositories and sharing of information and preprint publications have enabled us to make advances at a much quicker rate than we otherwise would have been able to do. And AI is struggling to keep up in that sense. So a lot of the systems that we might have applied, or we might have thought we could apply, they are suddenly struggling because the context has changed so dramatically that the training data that they were first trained on doesn't necessarily reflect the world as it is now. Of course, there are examples where there is a great collaboration or a combination of the two. One of my favorites is a forecasting project led by researchers at Carnegie Mellon University in the US. And they combined 3 different methods: 2 statistical models and predictive models that produce a nowcast and a forecast of the spread of COVID. And also they draw on crowd predictions, and they integrate all of those methods in order to produce their final forecast. And over the last 5 years, this is the group that has been most successful at predicting influenza-like illnesses in the US. So I think there's a real kind of interesting opportunity to see and test the limits of which parts of the problem we can rely on AI to help us solve, and where we really need these kind of established networks of people. And we're ultimately a social species. So I think that's the most exciting kind of part of how we can get even better at addressing problems together.
And Durrani, you talked a bit about real-world insights being crucial, and using human-centered design, for instance, to capture those perspectives. Can you just say a little bit more about how you see this relationship?
Yeah, I mean, just picking from what Alex said, that humans are complex, and they are, the way they think changes across space and time. Data and digital tools can't codify everything that humans are acting, right? So your phone cannot be a representation of who you are across space and time. So that's why it's extremely essential to have human intelligence, which is the non-codified bit that can complement with all the data crumbs from digital tools together to better understand complex system. So in our case, for example, in the example that I gave, I mean, rural communities, for whom we work most of the times, they are the most data scarce ecosystem. I mean, they don't release any data crumbs. They don't use phones like us. They are starting to use now, of course. So the thing is, we might get all these fancy high-resolution satellite imageries and start understanding what the communities are doing. But unless and until there's this ground intelligence from the local communities, which are data scarce currently, unless they are combined with this machine learning AI and big data sources, only then our solutions will become more sustainable, or not we'll just become like a fancy one-off innovations and then die off. That's been our experience, actually.
Right, and give an interesting sketch where we're at now. Yvonne, I'm interested in turning to you now to talk about where is this going. So if you cast your mind 4 or 5 years ahead, in the context of human rights violations, where do you think we're going to get to?
Oh, is it me? Oh.
No, I was asking Yvonne about in her context.
Sorry. Yes, where are things going in the next 5 years or so? The short answer is I'm not sure. Of course, we can hope that citizen-led evidence will have an increasing influence on accountability processes. We can see small pockets of that happening already, but just to pick up on something Louis said at the start, people are resistant to change, and the legal profession is no different. Courts address this kind of evidence with a sense of wariness, and I think some skepticism is to be expected and is to be welcomed. Actually, the danger of this going too far would be that we would see less reliable evidence seeping into court processes, which would be no good for anyone. So I think we can increasingly, especially I think in the post-COVID era where we have restrictions on travel, we can hope that citizen-led evidence will lead to a greater democratization of investigations. Investigations, I think, are going to increasingly move online using these open source platforms to find out what's really happening. We can see it in the US, for example, with attacks on protesters in Black Lives Matter protests, that people are using their mobile phone as a tool almost to protect themselves and to show what's happening. So that's my hope. It's not without challenges, and I think this is where we can look at AI and other machine learning tools that can be used to help filter the evidence that's the huge volumes of evidence that is posted out there. And then it's really about informing courts, informing judges, the legal profession about the value of this kind of evidence, about techniques around the verification of evidence, and upskilling, really, so that the legal profession is ready to meet the challenges of open source evidence and to harness it for good.
So you see the main challenges being how the legal profession catches up and adapts its institutions. But I was going to ask you about things like deep fakes and the other big challenges to this actually working.
Yes, yeah. Deepfakes, I think, is a massive issue. I think it's challenging at a pretty fundamental level our trust in evidence. And we can see how deepfake narratives can be harnessed by, people who wish to deny the existence of this evidence. So almost invariably when, let's say, a video of an atrocity happening is shared widely online, the perpetrators, people associated with the perpetrators, are out saying it's fake. But at the moment, deepfake technology isn't so advanced that, at the moment there are tools that we can use to figure out what are deepfakes. As that technology gets more advanced, then the techniques we use to figure out what's real and what's not, what's been doctored, will have to adapt to adjust to this and to figure out that. But I think it's a pretty fundamental challenge to this kind of evidence and to fact finding in general.
Thanks. And Lewis, can I ask you to comment on this future gazing, but can I actually ask you more about the immediate application first? Because one obvious thought in relation to swarm AI is whether the very different disciplines that are currently being used to predict COVID response and a second wave, whether we can use your techniques to improve the way in which our scientific advice is synthesized and interpreted. But then also, perhaps I'd love you to talk more about political decision making in the longer term and how Swarm AI can be applied there?
Yeah, so I mean, the underlying principle of Swarm AI is that people are smart, and we shouldn't just throw people out and replace them with AI, which has really been the trend over the last few years. And people have been so excited about AI, they said, let's replace people with the ability to just process data. Now, COVID's a good example of something completely new. There is not historical data that tells us everything we need to know about COVID and how to respond. And so it's a perfect example of the type of problem where human knowledge, human wisdom, human intuition should be harnessed. And so swarm intelligence is a perfect way to combine the power of AI and humans to allow us to aggregate and harness and optimize that knowledge. And we see it not just in things as important as COVID, but also in just pretty mundane things throughout the business world. All across the business world, we've seen this push to replace human decisions with AI decisions. We work with lots of Fortune 500 companies, and they've been working to say, hey, can they replace their sales forecasting with just processing data? And what they've discovered over the last couple of years is that when they use historical data and AI to predict sales, what they're really doing is predicting last year's sales, because that's the data that they have. And they are starting to realize, hey, the people in their organization, whether it's and especially if it's a diverse group of people from sales, marketing, people from all different types of locations, if we combine those people into a swarm intelligence, and we then use AI to amplify their knowledge and wisdom, they can generate significantly more accurate sales forecasts, just like doctors can generate more accurate diagnoses.
And Durrani, it's kind of same question for you, really. What are you most excited about in the future in your world?
In our world, I'm really excited about the rural communities going digital, because that has been the most data scarce, ecosystem. We're getting prepared for it. I mean, currently, as many of these examples have been shown, that most of the training data is biased towards people who have who are in urban areas and who use digital tools. But now with rural communities, Indonesia is a very good example where mobile money is becoming a big thing, even in rural areas. So now we are going to start capturing very unique things, new things about rural communities that we would never have understood. It's just getting prepared for that and learning from experiences from what we've done in the past with the urban communities, for example.
And what's going to get in the way in realizing that potential?
Data access would be one issue, but that's a very that would be a relatively small challenge compared to bigger challenges like understanding of what success is, what sustainability is, and how these data sources that are there, how are they able to answer these questions. So there's a simpler problem and there's a more complex problem. The simpler problem is in terms of, say, digital tools and data access with like private sector companies, ride sharing data. But that is eventually going to get solved. But the real challenge would be then, what do you want to understand? What do you want to see? And whether the data sets that are available answer those questions.
Thank you. And Alex, in the final minute before we go over to Q&A, I know you've been doing some work on creativity and how collective intelligence and AI can actually foster new forms of creativity. Can you just say a little bit more about that, Hope?
Yeah, I think it's one of the most exciting new technologies out there. So in our research, we came across a system called generative design, which has been developed by Autodesk. And it's a generative AI system, which at the moment is mostly being applied at a kind of individual level to help designers to come up with new ideas for product design and product development. And I think that if we pivot slightly and look at the kind of success and collaborative cultures that exist within gaming communities and start to think about how we can integrate both generative design and collaborative creativity that we do see in game creation, we can think about how we might use those technologies to solve public problems. For example, in urban environments, how can we use that to involve more communities in urban planning and helping to stretch the imagination of what is possible that satisfies everyone's constraints, but also helps them to explore new ideas. I think it's this kind of idea of extending and transforming creativity, but also providing new capabilities for groups of people to develop shared mental models, which can then be manipulated and adapted, is really exciting, because at the moment we do that to make decisions anyway, but we do it at the individual level. So having the technology to allow us to do that, to make better things together, I think is incredibly exciting.
Thanks very much, Alex. And thank you very much to all of the speakers. I'm going to invite all the audience now to join us for a 30-minute Q&A for more discussion. Just to say, at Nesta, particularly at the Centre for Collective Intelligence Design, we're doing a lot of work about trends in AI innovation, how AI and collective intelligence can come together, and how we can build a better evidence base. And do join us for Nesta's AI Spotlight Week, the week beginning of the 15th of June, where we'll be bringing together all sorts of activities with special features and events. With that, thank you again for the speakers, and we'll see you over in a few minutes to take some questions for the next half an hour. Thank you very much.
Thank you. Thank you so much, Ravi. A big thank you again to Yvonne, Louis, Alex, and Durrani. It's such an interesting conversation, one that transcends sectors and industry. And if you're as excited to carry on the conversation, if you're logged in over on the platform, you can now move across with your to join the panel for a deeper dive into the questions and answer session, as Ravi mentioned. We'll be back at 3 p.m. for a fireside chat coming up, and the topic is going to be around research and collaboration. So we'll be hearing from Facebook AI. Please do join us online, join the conversation with our hashtag CogX 2020, get involved and meet your virtual attendees on the platform. I'm going to go and get a quick cuppa and be back at 3 o'clock, and hopefully I'll see you at the next session. Thank you all. Good afternoon and welcome back to the Cutting Edge stage here at day one of CogX 2020. My name is Anushka Sharma and I have been your host to take you through the proceedings today. This is the Cutting Edge stage. This is where we're learning about tech that's being deployed for sort of research purposes and really looking at how technology over the next 12 to 18 months is really going to help you with your strategy for what you're laying into your businesses over the next 5 to 10 years. I'm really delighted to introduce our next session, which is on the power of collaboration, research and community. And I'm delighted to introduce our host for a fireside chat, Irina Kaufman, who is the director and business lead at Facebook Artificial Intelligence. Irina, welcome to you in California. Thank you for joining us.
Hi, everyone. I'm really grateful to be here and presenting and be part of CogX this year. My screen's up. Perfect. My name's Irina Kaufman, and I lead the Operations, Marketing, and Program Management Group for Facebook AI. Across the organization, there is a tremendous amount of innovation happening, both from fundamental research as well as applied research. Today, we'll be sharing how collaboration plays a key role in much of this work. I'll start with a high-level view of what does working in AI at Facebook really mean for us that are here, followed by the role that cross-functional teams play, as well as several examples of how broader collaborations amplify the work's potential. Navisa, a teammate of mine, will then share a deep dive into the FAST MRI project. At Facebook AI, we're working on connecting people to what they care about, powering new, meaningful experiences, and advancing the state-of-the-art through open research and accessible tooling. AI is core to Facebook now. Today, it could not exist without AI. We use it across our family of apps. For Facebook, AI isn't an experiment. It's an extremely important technology underpinning all that we do. We've deployed AI at a global scale. As you may have realized, I'm not a typical researcher or engineer, but have been fortunate enough to be part of some massive projects in the AI space. One of the things I value most about the AI group at Facebook is the commitment to partnership across functions and different roles on the team. We realize that the best work is enabled through collaboration amongst all different skill sets. While engineering is core to the work we do, there are a bunch of teams we work with, including design, product management, user research, and analytics. The collaboration extends beyond our internal teams and is the crux of the research culture. While we strive to be advancing the state-of-the-art in artificial intelligence, we often do so through open collaborations with the community and academia. One example of a cross-industry collaboration is the Deepfake Detection Challenge, which we launched with partners late last year. This was an effort where the community, including multiple industry partners, academics, media partners, and civil society organizations, came together to help detect manipulated media, in particular, deepfake videos. Together, we released the largest data set of its kind. This took tremendous effort and rigor to do responsibly and enable the world to have access to the data set to also help make progress in the space together. Over 2,200 teams participated and 35,000 models were submitted. We realized that many challenges we see today are global challenges that we're stronger to tackle as a community. The challenges of harmful content, for example, affect the entire tech industry and society at large. Facebook AI believes the best solutions will come from open collaboration by experts across the community. How many of you have seen a meme or even sent one to a friend? When we see these, they often elicit a reaction. It seems pretty straightforward what the message is, so how can they be any use to helping us learn about harmful content? Well, you have harmless images and harmless text, but when you combine them, the meaning can become mean. Swapping in different images and the meaning becomes harmless again. However, when you change the mix of text and images, you can create benign confounders to test classification systems and help them learn. When viewing a meme, we don't think about the words and photo independently of each other. We understand the combined meaning together. This is extremely challenging for machines, however. because it means they can't analyze the text and image separately. They just combine these two modalities and understand how the meaning changes when they are presented together. In order for AI to become a more effective tool for detecting hate speech, it must be able to understand content the way that people do, holistically. To catalyze research in this area, Facebook AI has created a dataset to help build systems that better understand multimodal hate speech. We released the Hateful Memes dataset to the broader research community and launching an associated competition hosted by Driven Data. The dataset contains over 10,000 new multimodal examples and images licensed from Getty Images. So that researchers can use the dataset to support their work, we also released the code for the baseline trained models. Engaging with the broader community and researchers to tackle tough challenges is in our DNA. And this effort is one example of partnering for research on hateful multimodal content. In addition to sharing datasets and work through joint challenges, we also share our open source frameworks, tools, libraries, and models for everything from research exploration to large-scale production deployment. PyTorch, for example, is an open source machine learning framework that is used by both researchers and developers to build, train, and deploy ML systems that solve many different complex challenges. Last year, the PyTorch team hosted a hackathon for the PyTorch community to build innovative, impactful models, applications, and other projects that create positive impact for businesses or people. Over 1,400 participants took part, representing over 90 countries around the world and 70 projects. On June 22nd of this year's hackathon will kick off on devpost.com. With an additional category added this year on building tools for responsible AI development. PyTorch is truly a community-driven project, and we aim to provide an opportunity for the community to get together, educate, challenge each other, and build something innovative and impactful. With that, I wanted to thank you for allowing me to share some examples today and give you a glimpse. Given the power to accelerate research we have when working together, I hope these collaborations continue to allow us to drive innovation and bring about cutting-edge research advancements. Next, Nafisa will share a case study on our FAST MRI project, where partnership has led to impact.
Thank you, Irina. So before FAST MRI, let's talk about the MRI itself. Many of you probably have been in these big, loud machines, which generate beautiful images of our internal organs. But there's a problem with it, right? You spend a lot of time, if you've been there, you know, at least 20 minutes, sometimes up to an hour. People are asked to hold their breath. So it creates a problem, and solving this would impact big group of people, including people who are too sick to stay still. Let's say you are feeling dizzy and you can't stay there for an hour, or children who don't have the concept of staying still. Also, MRI does not cause any radioactive, does not use radiation, so it might be preferable compared to other imaging modalities that are faster. And most importantly, it would increase access to MRI across the world. So for those of you who don't know how MRI works, after you go into scanner and go get the final beautiful looking image that doctors interpret, there's something goes in between. That's what we call case space, because MRIs are gathering data in a frequency domain, and it's usually not interpreted by a human, but that's where the raw data is. And if you look at it, when you fully sample the traditional way, you're sampling line by line and generating beautiful looking image that you see in the upper part of my slide. But if you want to undersample, meaning make it faster, that's the one way to do it. So you're inherently, let's say, only gathering 25% of the original raw case-based data, but then the images don't have enough data to look original. So they have these artifacts, as you see in the bottom part of my slide. So this is where we're thinking about coming in with fast MRI. The idea is, can you undersample the data, raw data, and still generate images that look accurate and as good as the previous ones? And why is it an interesting AI problem? if you might have seen like out there, like celebrity images, their faces being generated by machine learning algorithms and looking, pretty accurate. So we started thinking about, can we put these technologies into good use? And but there's a challenge when it comes to medical imaging. Getting little details is very important. So in this image, you see part of the knee MRI where the damage in the meniscus is only like few pixels large. And traditional metrics that use the natural imaging do not quite work well to detect what has gone missing in the reconstructed image, what hasn't. So evaluation becomes a very interesting problem for medical imaging, and pushing the AI algorithms to do more. So our challenge is threefold. One is in medicine, there is a lot of data generated, but not so much shared. So there aren't really data sets that can you use as a benchmark. And one of the things for FastMRI we needed was to create a data set that could be used by all the researchers solving the same problem. And number two was come up with evaluation metrics. And of course, algorithms who can do can be used to do reconstruction. So this is the most important part of the FastMRI project, I would say, is to finding the right partnership, because you can solve, as a machine learning researcher, you can solve problems using existing, public data sets or something. But if you don't work with experts in the field that can use complementary expertise and build solutions together, it's less likely to be adopted. So this was at the core of our partnership with NYU Langone Health Institution in New York City, which is known for their being, medical research institution. It was dedicated MRI imaging department, team of physicists, doctors, engineers, machine learning scientists working together. And we have teamed up with them to work on this problem together. So we, get help with them in their every step of the, the decision making, the clinical expertise and other expertises they can offer, make sure we're solving the right problem with them for the real world. The other part of the partnership that's important is that they're providing real world data set, one of the largest, and they put it out there. So you can go to fastmri.org and download it and use it for your research as well. And everything done with IRB approvals and their ethical research practices. But then very important part was having the same spirit like the Facebook AI research team has, that having a philosophy of open scientific research, meaning everything we do together is open sourced and put up publicly, published, so anybody could use and develop further. With that, I wanted to say that we do not intend to so much of replace doctors. A lot of people think of when AI is using in medical imaging, or we do not come up with solutions and ask medical community just to use it. The philosophy behind this collaboration and partnership, why is it quite powerful, is because the idea is to empower the community in both medical and AI research community to work together by providing them a gold standard benchmark data set that anybody can use and have metrics that can be compared with each other with what's the best image reconstruction metric, and then open source models that people can use and compare and build upon. So with that in mind, last year in December, we hosted a public FastMRI image reconstruction challenge. You can go to fastmri.org to learn more about it. And we still have an open leaderboard, meaning you can download the data, develop your own reconstruction methods for making MRIs faster, and upload your results to the public leaderboard and see how you do compared to other researchers. Maybe there are lessons learned that can be done together. So the results of this challenge was very interesting, because we saw many people using different methods than us to solve the same problem, which was the purpose of encouraging more of the community to come together, because there are very interesting problems in medical imaging and AI that are often not challenged if you're only working on the natural image space. So medical imaging creates like very interesting problems to push the AI forward. With that, I think if you want to learn more about the Facebook AI, you can check our Facebook page, and also we're on Twitter at Facebook AI. You can always ask questions by emailing. We also have contact at thefastmri.org if you want specifically ask about the project. But with that, I want to conclude my presentation, and thank you. And I hope you enjoyed the rest of the conference.
Thank you so much to Irina and to Nafisa from Facebook AI there. This is the cutting edge stage. This is day one of CogX 2020. We've just had a wonderful fireside chat from the team at Facebook AI, who are based between California and New York, a truly global experience today as people from around the world join us for the first virtual edition of CogX. We're going to be back on the cutting edge stage from 5 p.m. We'll be having a session on empathetic AI, and I look forward to welcoming you back then. In the meantime, make sure that you're tweeting and sharing your nuggets of information and what you're learning with hashtag CogX 2020. Make sure you get on the platform and network with your fellow virtual attendees. And we very much look forward to seeing you back here on the cutting edge stage at 5 p.m. This is Anushka signing out for now. See you soon. Good afternoon and welcome back to day one of CogX 2020. This is the cutting edge stage. My name is Anushka Sharma and I'm here to take you through the proceedings today. I sometimes wish you could actually understand and listen to some of the tidbits that we hear in the green room, but you don't have long to wait before you hear from our next panel direct. This is the cutting edge stage. We're talking about technology that's coming up over the next 12 to 18 months that's really cutting edge and at the bleeding edge of technology. And it's here to inform you on this platform of how that might fit into your strategy over the next 5 to 10 years. So I'm really delighted now to introduce the Director of AI and Data Economy at Innovate UK, Zoe Webster, who will be leading our next session. Over to you, Zoe.
Thank you very much, Anushka. Great to be here. I remember being here last year, different circumstances, but really great to hear about some of the cutting edge developments that are going on right now and what they might mean to you and your ventures. So we're here to talk first of all about empathetic AI and what that means. Essentially, this is around thinking about empathy in the context of AI, and rather than having empathy as a kind of a tick box to tick off when you're developing AI to make sure you're fulfilling that, it's actually about putting that at the heart of what AI is doing and delivering, putting empathy and emotion at its very heart, and helping to have that set to the intentions going forward. Got an amazing panel of speakers to talk to you now about what that means to them and what they're doing to develop empathetic AI going forward. Now, first of all, I'm going to introduce you to our first speaker, our keynote speaker for this session, Dr. Philippe Baudouin. He co-founded Element AI, a world leader operationalizing AI for businesses. In his latest venture, she started this year, he and his team are creating an empathetic AI that curates personalized content for the person we wish we were. This new startup recently secured seed funding from Founder Fuel, one of Canada's most prominent tech accelerators. So really pleased to welcome you, Philippe, to the stage. Please, go ahead.
Thanks a lot, Zoe. Thanks. So yes, as you mentioned, starting with a little keynote presentation here. Maybe we can go to the first slide. There you go. So yeah, I'd like to start this story a few decades in the past. At first, there was the internet, there was the web, and these things came with big dreams. Talking about this dream, the inventor of the World Wide Web, Sir Tim Berners-Lee, once said that the web is more a social creation than a technical one. He said, I designed it for a social effect, to get people to work together. And so now the dreams of that era came to a swift close as gigantic media corporations took over, and they started filling our feeds and our lives, not with what we want, but with what they assume that we want. So today we're left in the diseased days, and we're unable to decipher what is real, what is fake, what is good, and what is evil. So we've known for a while now that the way we've been consuming information just isn't working. We are tangled up in algorithms that are definitely good for large tech companies, but definitely not good for us. So look, the habits we formed using these platforms, these habits are hard to break, right? Especially since the delivery mechanisms themselves are kind of designed to make us addicted, right? The lure of social media and the empty dopamine hits that it provides are by design irresistible. So how did we get here? Where did we go wrong? There's been many hypotheses suggested over the years to explain that, but I'd like to suggest one new hypothesis today. Because of these algorithms and what they do to us, we're simply not ourselves when we're on the internet. In fact, I'd be bold and I will say that we're much better people than what we look like on the internet. So then the question becomes, who are we? It's an important question, and it seems to be the question that all the big web giants are trying to answer every day. right? They profile us, they model us through our clicks, through our likes, through the speed at which we scroll on their mobile apps. They measure that. And they even go so far as to pretend that they know us better than we know ourselves. I beg to differ. Most of these clicks and these likes and these scrolls are happening beyond our consciousness. We are not consciously aware of the impact of our actions on the algorithms that have so much impact on our lives. So in a sense, our clicks are very shallow signals that we're sending and that are being used to train our algorithms. In turn, once they're trained, these algorithms send us shallow recommendations, naturally, And these posts that they give us back, they're meant to trigger our emotions, to make us more anxious, to trigger our anger, to polarize us or divide us. They're doing anything they need to do in order to get that next click or to get that next like. And since we spend so much time with these algorithms, well, they eventually get to us. These shallow recommendations make us shallower, at least online. So this diet of shallow signals, which is being fed to our algorithms, well, this diet is born from an almost universally held belief in the Silicon Valley, something that I would call the myth of frictionlessness. This myth goes as such. It says that any piece of technology can be made better if we reduce friction. And at first glance, it makes a lot of sense. If you are there to, make some piece of technology that makes our life easier, then if it takes something difficult and it makes it simpler, it's always better, right? Well, the thing is that there are many different kinds of difficult. There is this kind. That's the type of difficult work we definitely want to get rid of, right? Because this difficult work doesn't define who we want to be. That's why we buy a dishwasher, or that's why the first person who invents a machine that can fold your laundry is going to, become a millionaire. But then there's this other kind of difficult work. The blank page, the white paper, total freedom to write your own story, to decide who you want to be. That's difficult. There's no social platform that would ever dare put their users in front of a white page like that, even if it allowed them to understand users better, because it causes too much friction. It would send all their metrics in a tailspin. Conversion rate, click-through rate, engagement, time on platform, all the numbers the large tech companies, or even any company in the Valley, all the numbers they care for would crash instantly if we asked users to face a white page like that. So what do? Well, they reduce friction. They give us simple buttons that we can click mindlessly. They measure signals we're not even aware we're emitting. And the reward is better metrics for them. But the cost? The cost is shallow signals, and the cost is shallow users, shallow you. So how do we fix this? First, we have to give up on the myth of frictionlessness. We have to realize that the only way to understand people is to give them a space in which they can stop and think. A space in which they can use their own words rather than the ones we put in their mouth. So that's what empathetic AI is about. In a sense, empathetic AI is not so much a new invention as it is a new intention. It proposes to use recent advances in natural language understanding so that we can let people express their wants and their needs in a more nuanced way. It proposes to embrace the friction that it creates. Empathetic AI is inviting us to move away from the current trend of in-your-face technology and towards by-your-side technology. That intention is not an easy one to embrace, however. As we've seen, empathetic AI increases friction, and therefore it's not compatible with Silicon Valley's favorite metrics. If we ask a user to stop and think, well, there's a chance they will decide to simply leave our website or, quit our mobile app. But, as technologists, it might be a risk we need to take today. Otherwise, we risk simply not understanding our users. There's something else that empathetic AI is not compatible with, and it's Silicon Valley's favorite business model: advertising. There is no way we can create a space in which people will thoughtfully express their wants and needs if they believe that our ultimate goal is to push them advertising. So we have to give up on our beloved metric, and now we have to give up on our beloved revenue stream. That's a tough thing to ask. Now, there's a third thing that empathetic AI is not. It doesn't have to be boring. Yes, it's difficult to fill an empty page, and no, we don't want to put words in your mouth, but we can still make the journey incredibly fun. Empathetic AI is about all the ways in which we can spark the imagination of people, and we can help them find their own words, the words that will empower them so that they can take control back over their algorithms. There's an idealist named Vint Cerf who once said about the internet, which he happened to have co-invented, if we do not like what we see in that mirror, the problem is not to fix the mirror, we have to fix society. Well, I believe we broke Vint's mirror, and I believe we need empathetic AI to fix it, so that we can go back to an internet that shows us as we really are, rather than as these distorted, shallow images we project today. If we do this, then we may be able to provide a better answer to the most important question: who are we? And if we provide a better answer to that question, then if we're able to let these better versions of ourselves shine online, then we may be able to bring back the dreams of the founders of the internet. Thank you very much. And if you're interested in empathetic AI, just wanted to point out a couple of links here on that last slide. We are just building a startup that is putting empathetic AI at the core of our product. We're still in stealth mode, so you'll find us at stealthstartup4.com. But if you're interested in the topic, you can follow that space. Thank you very much.
Thank you so much, Philippe. That was fascinating. And before I introduce the other speakers, and we'll have some discussion as a panel, I just wanted to remind you to use Slido. If you've got any questions for the panel, we'll come to those later. I think you'll find the code on the platform. I think it's 3056 with a V at the front maybe, but that's something that we'll have checked for you. So if you've got any questions, do note them and send them through Slido, and we can pick them up a little later. So now we'll come to our other speakers on the panel. It's my pleasure to introduce you to Christine, Amber and Jonathan. So Christine Gloria, Dr. Christine Gloria, forgive me, is Associate Director of Emerging Technologies for Aspen Digital, a policy program of the Aspen Institute. Her work focuses on the nexus of trust and emerging technologies. Specifically, she leads the Virtually Human project, which examines the opportunities for and challenges of continuous and ubiquitous digital connection on individuals and meaningful social connections. Next up, we've got Amber Case, who's a futurist, author and researcher. She studies the interaction between humans and computers and how our relationship with information is changing the way cultures think, act and understand their worlds. She's researcher at the Institute for the Future and the author of Calm Technology and Designing with Sound. Amber has received multiple awards and was named one of Inc. magazine's 30 Under 30 and Fast Company's most influential women in technology. And Jonathan Morgan is founder and CEO of Yonder. Prior to Yonder, he published research about extremist groups manipulating social media with the Brookings Institution, The Atlantic, and The Washington Post. Presented at NATO's Center of Excellence for Defense Against Terrorism, the United States Institute for Peace, and the African Union. Jonathan also served as an advisor to the US State Department, developing strategies for digital counterterrorism. He regularly provides commentary about online disinformation for publications such as the New York Times, NBC, NPR, and Wired. So thank you very much for panel members for joining us. Everyone's got so much to contribute. And I'm looking forward to hearing your questions for them a bit later. So they're each going to speak in turn. So Christine, if you wouldn't mind taking the floor.
Yeah, absolutely. Thank you, Philippe, for that wonderful presentation. I think it set us up quite lovely into what I hope this discussion will evolve into. I just wanted to quickly point out that with the Virtually Human project, particularly in the approach at Aspen, we look at what exactly Philippe was explaining it very nicely in his slide deck about the idea both of the lens of the individual. So how does the technology impact the person's emotional, behavioral, and psychological, like how does that manifest in their lives based on the interaction with the technology? And then how does that inform our technology design in the later, which leads to the social connection portion, right? So with all of the potential interactions that we're having, particularly virtually online, through Facebook, through Google, through you name it, there's so many. What is sustainable? What is not sustainable? Given how we've been put together, programmed to have social connections. What does that mean in the future? And then lastly, trying to really understand where the business case is here, right? Because as Philippe was saying, does not fit into the Silicon Valley mode of working with advertising, with understanding what will make money from this, right? We're all still trying to operate in the economy. So trying to figure out where the business case is here. And I think what we're seeing with COVID and what we're seeing particularly in the US with the protesters is a lot of instances where technology and our understanding of technology and its impact and influence and integration in our lives is full steam. And we're seeing where things are just falling short. And whether that's a government policy question, whether that's a platform question, I think we're starting to realize, and excellently, like Philippe said, who are we? What does this really mean for us as a society and as for individuals? And I think we're in a really, I'm going to be positive here, an opportunistic moment that we can kind of reassess how we're going to apply what we understand about being human, what we want to be about, and how society will get there, and then put the correct correct metrics and or rail guards that we need on the policy side to help us get to a future that we actually want to be a part of. So I'll leave it at that. I look forward to hearing what else everyone has to say and jumping into conversation.
That's great. Thank you so much, Christine. Before we come to our next speaker, I just want to make sure I let you know that the Slido code is actually V3722 for this session. So hopefully that's useful information, but please do send your questions through. Now, Amber, I'd like to invite you to step up and give your perspective.
Thank you. It's really wonderful to be here. I'd like to give a short talk about building technology at human scale and what that actually means. The concept of human scale is partially from architecture theory, but it's also much more indigenous in origin. The idea that you could make something with the resources around you, that you're connected to a local ecosystem, and what distance actually means when we're talking about operating at scale. I also tried to outline some principles for empathetic automation, and I'll share those a little bit too. But I'd like to begin with a quick story. A few years ago, I was in Kerala, India for a developer conference, and there was this wonderful woman that took the stage, and she gave this amazing story. She said, look, I came from this engineering family. I was into math, I was into science, and I was really good at it. I was an exceptional programmer, but I decided I wanted to be a designer. So I Googled how to be a designer. And one of the things that it said that I needed to be was somebody with empathy. She said, I had never heard of empathy before. I don't know what that is. You know, math, science, what's empathy? So she looked up what empathy was. And she said, okay, I'm just going to have to learn empathy. And over the course of a couple years, working with the definition of empathy, of the ability to understand and share the feelings of another, she became an exceptional user experience designer and holds a very high level position at Microsoft and is helping to restructure a lot of the divisions of the company. This was a fascinating story for me because I grew up in a very similar family. I grew up, I guess you call it like a third generation AI family. My grandpa worked on the fourth node of ARPANET at the University of Utah, which was the first internet. He worked on AI systems and 3D computing. My dad worked on voice concatenation systems and automated phone trees at a big telecom company. And when I was growing up in the 80s and 90s, our Sunday conversations were all about ethics and empathy and AI. Can an AI have feeling? Can you train an AI to be like a human? Can an AI understand what it feels like to touch grass on a July day when it's cool outside and you just had a nice barbecue with your family? What does that mean? Are machines more important than people? Are trees more important than people? And we would just argue and fight. And I would always take the idea, the kind of nasty idea that like technology should just keep going. It doesn't matter. You know, people are dumb. and my dad was trying to give me an ethical and empathetic education while I got so excited about the family Atari and I wanted to program and all I wanted to do was have black and white answers. I wanted to do mathematics. And I kind of realized later on, after I kind of burnt out, that I was missing something. And so it wasn't until I decided to go to college that I called my mom's best friend up and I said, hey, you know, Carmen, you're a fantastic mathematician. I want to become a mathematician or a programmer. I want to go to MIT or Caltech. What should I do? She said, well, don't do any of that. You should learn how to think. You know, you should learn some ethics. You should go to a liberal arts college and you should learn something else. Pick the subject that you're the worst at in school and do that. So I got a scholarship to Lewis and Clark College and I majored in anthropology and sociology because I got D's at some point in social studies, but I was always 100% straight A student in math and science. And what I learned in those anthropology classes by writing my thesis on mobile phones in 2007, right about when the iPhone came out, was that my ideas about the world needed to be significantly expanded if I were to be able to make technology that worked well for people. It was really, really tough learning these things. And I think, you know, my question always has been, can people learn empathy? And if you have people coming out of college immediately who are like me, who just wanted to do math and science, and they go immediately into creating what they think could be a perfect system where there's no flaws from a mathematical universe, then you have an issue where you have people just blaming somebody if they don't use the system right. It's not that we're bad at technology. A lot of the technology is bad at us. And a lot of times when I see automated systems, I see people apologizing on behalf of them. I see an automated check-in counter and it doesn't work. And so the person at the front counter apologizes. They say, I'm so sorry. I wasn't able to make this work for you. And I think one of the reasons why is that we're operating at remote control. Developers are developing for unseen people. And so if we actually recenter technology to where people can actually operate it close to themselves and change it for their own needs, there's ways that we can have our own empathy for our communities and how we know about what we need be operated into the system. And developers building these flexible platforms where we can see what's being done in the background and there's transparency and they can actually feel and see how we're experiencing the system could lead to a more empathetic understanding of what people really need and less of a blame on people aren't doing things the right way, and the consequences of that. So that's a short thing. I'll wrap up. Thanks for listening.
Thank you, Amber. That was great. Thank you. Jonathan, can I invite you to the stage, please?
Yeah, absolutely. Thank you for the invitation, and I really appreciate the just the. This has been a really provocative conversation already, so hopefully I can add something at least a little bit meaningful. I'll do my best to keep up. But I wanted to follow on a little bit from what Amber was saying. You brought up a really interesting point about this, like, I think this dichotomy between this objective kind of rational world of math and programming and this more kind of empathetic human world, and really trying to figure out how we can blend the two together. And I have my experience has been very similar, where I took a detour after high school. Most of my career has been focused on technology, but my university degree was actually in performing arts. I went to a performing arts conservatory and learned how to make like shared human experience, like based on common empathy. That's more or less the goal when you get right down to the nuts and bolts of kind of why live performance and these shared experiences are essential. And then like a lot of people with that background quickly discovered that a career in technology is equally as rewarding and a little bit more viable. And so like back down the technology path I went. But like the blend between those two disciplines, is kind of deep understanding of how machines reason about the world, and this deep understanding about how humans experience shared empathy, I think really led me to believe that it's essential that we blend these two disciplines in the way that the other panelists, I think, are already advocating. And we have models for this. There's actually, I think the disciplines of interaction and user experience design actually give us this sense of how do we focus on a human-centered approach to creating a more of a dialogue or a collaboration with technology, as opposed to, like Amber was just saying, this idea of like this idealized idea of a complete system that is flawless, that is inherently objective, that makes decisions in a way that is almost like a little bit smarter than the humans, like kind of like does things on their behalf, or like Philippe was saying, kind of curates content in a way that assumes it understands what the user wants or what the user is trying to accomplish, but without engaging in a dialogue with any individual human being. And so like this is a big thing. At Yonder, we talk in a similar way that Philippe was talking about kind of empathetic AI, we talk a lot about an authentic internet at Yonder. And we talk a lot about authenticity and what creates an authentic human experience online. And so in a way, I think this is a course correction of this kind of generic idea about social interaction online, that every input is identical, that there's wisdom in the crowd, and that somehow the sum total of all of our interactions produces some kind of latent value, or kind of that's somehow representative of the human experience. And I think we've all discovered over the past 3 or 4 years in particular that that's not true. There's inherent bias in every human experience. There's inherent subjectivity in every human experience, and that's baked into our technology. And we can't wish that away just by trying to do like machine learning at scale, or trying to have kind of smart machines operating at scale. And so I think this moving towards a model that is as emotionally satisfying as our human-to-human interactions is essential. It's where we need to go next as technologists. And so in a very practical way, I'm interested in the shared kind of blending of different ideas for artificial intelligence. So blending this idea that there's as human beings, we have a shared structure for our belief systems that organizes all of our collective and individual experiences. We've kind of designed our subjective interpretation of the world in a way that all of us can understand together. And then, so there's some relationship between what's called symbolic artificial intelligence and some aspects of deep learning, like reinforcement learning, transfer learning. These are very much in this mode of like artificial intelligence or technologies as a tool for kind of a more of a dialogue design-based way of augmenting, accelerating, and kind of benefiting from human intuition by assuming that humans are individuals, they're messy, but they're also smart and they understand what they want, and they can be partners in discovering what the technology is supposed to accomplish, as opposed to being almost like shoved to the side. So I'll leave it at that. I'm really looking forward to the conversation. I think this is a really fantastic panel with folks who have a lot of great ideas about how technology can evolve to be more human.
That's great. Thank you so much. There's already get some questions in, which is fantastic. I think there's a few questions around the difference between empathy and sympathy, and I just wondered if perhaps Amber or Christine could say something about the differences and whether it is empathetic or sympathetic AI we need.
So I'll just jump in here from a traditional, psychology standpoint, is that we've understood empathy to be both the understanding of someone else's being or feelings, and then being able to then reciprocate that. There's a lot of talk specifically now in terms of how that's being couched within the AI world is cognitive empathy. So you could essentially train a system to do the processes, right? To do the process of empathy, but not necessarily reciprocate the empathy to the user itself. So there's a little bit of work there. I would say, and this is just kind of my personal understanding of it, is that sympathy plays almost a branch off between empathy, right? Because it's like it's a reaction to, but not necessarily a reaction to an understanding, but not necessarily a two-way conversation. Whereas empathy, as I've mentioned before to the panelists, is this idea that there's a lived experience that comes to inform both the understanding and the reciprocation of the feeling or the emotion itself.
Thank you. Amber, I think you had something to say on this as well. There we go. Yeah, I've just been thinking about empathy and sympathy, and in terms of just having people available from lots of different fields in a space, which is a little bit of a tangent, but thinking about Xerox PARC, where there was deliberately hired anthropologists and historians and artists to counter this kind of all the very specific perspective of programming, and then also the idea that originally it was the arts and the sciences and they were bonded together. So there was this idea that artists would have empathy and sympathy, and that they were hanging out alongside people who were developing the technologies, and that's how we got the graphic user interface to begin with, and the idea of technology should be a pass-through technology, that technology can be invisible in that you don't focus on the task, but the tool, and the idea of a kind of craft that's associated with it. I just keep thinking about that, even though I never necessarily have the best definitions for each of the sympathy and empathy. It just seems like I always question whether these things can scale, like whether they work at scale or whether they need to be considered in small groups and communities. So in using technology at an enormous scale, can you actually have empathy? Or is it something that needs to be formed, on small forums and small craft? So I think that really helpful. And actually, one of the things I want to pick up on, kind of bouncing off that, is Christine, you mentioned lived experience. And I'm trying to imagine how we could possibly give AI lived experience or a sense of that to enable empathy. Can you say a bit how far can that go?
Right.
What Amber said about scaling.
So I think it's it's quite interesting because usually this is when the movie Her comes into discussion points, and you think about, well, yeah, you could essentially program an AI that has all types of experiences, multiple experiences from multiple perspectives, right? And so if that's the case, and you can, then would the reciprocation of the empathy be genuine, right? That's the second half of that question. And I think we as humans, I actually think that an AI could, quote unquote, have a lived experience if we're just looking at it as those data points that a person can have, celebrating a birthday, but whether or not they can then use that to reciprocate to a human, whether a human can feel as if it is being reciprocated is a whole different set of questions that we, one, don't have measurements for. We don't know how that would work. And two, a language to kind of understand how we would even ask that question to a human. Here's a robotic seal. Do you feel, how is that, what is that relationship or that interaction with you? And we've seen lots of stories here, right, where people do reciprocate to the Paro, right, or to their Roomba about how they, that relationship. The detriment there is what Philippe was, I think, pointing to, is that other half of that circle is then we are then given recommendations that are based on what these really underexplored responses are between that human and the robot or the system, that I think is problematic, and we just don't know how to do that quite yet. But to whether or not you could give an AI lived experience, if we're measuring it by the fact that it can have a birthday, it can be yelled at, if sure. Right.
I mean, the developers have lived experience. I guess there's something around that. So I know Philippe and Jonathan want to come in here. So Philippe, did you want to add something?
Yeah. So I love the way you're putting it, right? As you say, Christina, like this idea of empathetic AI, it summons the images of her and automated agents that really get us. Mm-hmm. But I think what I wanted to draw the attention to is, AI is sure the agent you interact with, but AI is also the entire process you build around, the user experience. And in terms of empathetic AI here, I believe it's much more about the intentions we have coming into the process of building a system that will assist the user than it is about the system itself. Mm-hmm. If coming into that process, our goal is to understand the user better, I think this is where we're being empathetic. And it's the designers as much as the AI itself that demonstrates empathy in a case like this. And what I believe has been happening is we left that behind. Because we fell in love with data-driven design and data-driven became a very narrow definition of data. It became quantitative data. Mm-hmm. Can you show me numbers? But these numbers, they capture something very raw, and it's not the nuances that we need in order to understand humans. So I guess my call for empathetic AI is more a call about, empathetic AI design, right? Can we actually think of the people as we design our systems? And remember that people are not on our website to spend more time, and they're not there to click more, and they're not there to convert. They're there for something else. And we have to figure this out, and we have to acknowledge that we won't be able to do this through the numbers we collect today.
Yeah, thank you. A good time to bring Jonathan in on the design point, I think.
I think that's a really salient point to talk about the design of these systems. And I think we often talk about this problem in terms of scale. And I actually think as technologists, because we haven't been very empathetic or thoughtful or intentional in how we've designed these systems, that we're trying to scale at the wrong point in the system. We're trying to scale at the quantitative computation layer of the systems so that we can have, under this assumption, which I think is a fallacy, that more data points will somehow, if we could just get enough different inputs about the user, then some understanding of them or some empathy would emerge, as if it were latent in all of these different data points about things that we click on the internet. And I think actually what we want is we want to scale the part of the system where technologists, I think, can have a lot of empathy for the user, which is like, what's the most relevant, what's the most specific, what's the most contextual, what's the most rich data that we can put in front of the user, or that we can use to get a better understanding of who they are. And those choices are almost editorial, and they require a lot of human empathy. I think they require a lot of intuition about what users are trying to accomplish. But then it means that the kind of machine learning or AI-driven approaches that we use to help interact with the user, then we're actually working on more like small batch artisanal data. Like it's the Portland version of data science as opposed to the New York City version of data science. And like I think that's includes much more, like it's easier to reason about. I think it's easier for technologists, it's easier for designers, and it's easier for users to collaborate around really curating like that data curation process. And then it makes the AI and ML significantly easier to accomplish and much less of a black box.
I had a couple of questions. I hope no one draws a link between them. But the first one is around how much technology developers really should care, should have empathy and actually should care. I think one of the questions we've had is around revenue models, and given that they are there to drive traffic and to drive profit, really how much should they care about the user? Philippe, maybe this comes from your keynote earlier.
Yeah, so, I mean, if you stop thinking about the user to think about profit, I believe there's something a bit off in the business model here. It's like, or it's optimizing for shorter term stuff. At the end of the day, if someone comes and cares about the user more than you do, they will win the user, right? Well, no matter how much money you can squeeze out of your process.
I think this leads on to the second question, which I hope people don't link too much, is that's come from the audience about, psychopaths don't have empathy but can learn it from others. Are we in danger there? Is there a risk that we will simply have AI basically a psychopath? That sounds quite a scary future. Is that something you think is a genuine risk?
Are you asking me?
I think that is.
No, but I mean, like a word about that again. I think we're really far from like a little AI companion that will be able to experience the world and connect with us at the emotional level. I think the empathy that I'm calling for again is more from how do we design AI in an empathetic way, more than so. Yeah, AI psychopaths. There's a future that has AI psychopaths in them. I hope it's not the one we're building.
I think that, yes, ditto. I think Christine and Amber, I think.
Yeah, so that's a really great question, because I think there's a lot of studies in the psychology realm that show that you can teach it, and the extent to which that might be applied into AI is where forming the correct language and understanding that this is a potential framework by which we need to both design the AI but understand the AI is crucial for policy making, for governance structures. Like this is how we then create the guardrails we need in order to protect us from things that could go off the rail, like a psychopathic AI.
Thank you, Amber. I think you wanted to add something.
I'm going to say that we already have psychopathic AIs all over the place. They're everywhere. They're in systems that help judges determine whether somebody should go back into prison or not. And under the guise of empathy, they actually just put in the racism of the system that they came from. And the judge can then say, oh, well, the AI told me to do it, and the AI is perfect, and therefore I can just systematically perpetuate whatever is there. And I think there's other systems that might be sociopathic, where it's just a parking meter that there's no way to tell somebody that it's stuck. There's no way to have somebody have it work out. It doesn't have any empathy with anybody, and reduces. They're all built for somebody who can see size 8 font. They're not working with people who have arthritis. And I think one of the biggest issues is that a developer can get hired on to do a thing. They might get hired right out of college, and they never even see it. The people whose lives are being affected by using that system, the millions of people they spent maybe a week thinking about it because they were on a deadline, and then they have something unfunctional, and then they get mad when somebody says, hey, this is terrible and here's a bug report. But if they were actually able to be there with somebody to experience what it was like, or trapped in a room with their own device, maybe they might change it. And a lot of companies do not have that. I know that at Airbnb, they actually had pods that you would sit in and you would listen to frustrated customer calls so that you could experience your design decisions. And that really changed how a lot of people built their systems over there.
Thank you, Amber. And just to wrap up, because I think we've got a minute left, one of the questions that came in was, what practical steps can we all take to drive the change needed for empathetic AI? If I can turn to you for 20 seconds each, what single practical step would you recommend that people take or look at taking to drive the required change? So perhaps we can start with you, Philippe.
Yeah, I would say whenever you make a design decision, ask yourself, is the user spending time thinking as they do that interaction? If they're not, then please don't overweight that signal as you try to train an AI system.
That's great. Thank you. Christine?
I would just make sure that there's diversity in both the process that you're putting together and in the user base that you're trying to make for, to allow for the different perspectives to be included.
Fantastic. Thank you. Amber?
I think whenever making a design decision, consider what it would feel like if you used it and whether it would be reasonable if other people in your family in different social classes were possible to use it instead of an abstract.
That's really helpful. Thank you. And Jonathan?
Yeah, I'd advocate for technologists at every part of the design process for an AI system, from data acquisition to data processing to the modeling work that I think gets the primary amount of focus in these sorts of conversations, is really look to the practice of human-centered design. Really teach yourself how to find that empathy in a technology context. So to Amber's point, you can put yourselves in the position of a user to imagine what it would feel like to interact with the technology that you're building and understand what that shared experience will be. And then, use your best judgment at all times.
That's amazing. Great advice from everyone, some practical steps. Thank you so much to the panel, to Philippe, to Amber, to Christine, and to Jonathan. It's been a great discussion. Thank you so much, everyone, for your questions. I will now hand back over to Anushka.
Thank you all so much. I don't know about you, but I'm one of those people that loves these conversations, and I had goosebumps all the way through that panel. Empathy, sympathy, technology, designing technology for humanity is one of the things that we've really been enriched with some fantastic insights from our panel. So huge thank you to Amber, Christine, Philippe, Jonathan, and of course Zoe. This is the Cutting Edge stage. It's day one of CogX 2020. This is where you learn about bleeding technology, what sort of themes you can take to grow your business strategy over the next 5 to 10 years. We're actually going to be running our next session in about 13 minutes, so back here at 6 p.m. UK time. And we're actually going to be talking about generalized artificial intelligence, the next decade for AI. So we really hope that you'll come back and join us. We love the engagement on Slido. Keep getting those questions in. Share it on Twitter with the hashtag CogX2020. And we really look forward to seeing you back here at the Cutting Edge stage very soon. Thank you. Hello, good evening, and welcome to the Cutting Edge stage. This is CogX 2020. My name is Anushka Sharma, and I'm delighted to have taken you through today's proceedings here on the Cutting Edge stage. It's been an amazing day, and this is our final session. Where did the time go? I'm really excited to introduce the next session, but don't forget to join on Slido and on the platform and start getting your questions ready, because the panel will be meeting for a breakout Q&A session after this session finishes, after a short break at 7 p.m. So this is the Cutting Edge stage. This is where you find out about bleeding technology that's research-led, that is being worked on over sort of like the next 12 to 18 months. And it's something for you to factor into your strategy over the next 5 to 10 years. So I'm going to hand over and introduce to the wonderful Zoe Webster, who is from Innovate UK, who is going to be chairing this next session. Zoe, welcome back to the Cutting Edge stage.
Good afternoon or evening. So here we're going to be talking about generalized AI and the next decade in AI. Sounds like the holy grail, isn't it, to be able to take learning from one context or problem to another one. And people are starting to do just that in many contexts, and the work continues. And hopefully we'll hear from our stellar lineup a lot more about what's going on at that bleeding edge. We're going to hear from 3 panelists, and I'll introduce the second and third shortly. But first of all, we're going to hear from Anima Ankuma, who is a Bren Professor at Caltech and Director of Machine Learning Research at NVIDIA. She was previously a Principal Scientist at Amazon Web Services. She's received several honours, such as the Alfred P. Sloan Fellowship, NCF Career Award, Young Investigator Awards from Department of Defense. She is passionate about designing principled AI algorithms and applying them in interdisciplinary applications. Her research focus is on unsupervised AI, optimization, and tensor methods. So pleased to welcome Anima to the stage.
Thanks a lot, Zoe, and it's great to be here. I know this is later in the evening there in the UK, so thank you for sticking around, and welcome to my talk. So I hope you can now see my slides. So what I'm going to talk today is about where we are heading next with AI, right? The past decade has been amazing to me as an AI researcher. There's been so much progress, so much excitement about AI. So the question is, are we done? If not, where do we head next? What are the challenges that are yet to be resolved, and how do we get towards solving them? So when I think about what has led to the deep learning revolution, to me, it's what I call, excuse me, give me a second, sorry. To me, what I call the trinity of AI, right? It's not just what algorithms go into AI, it's also the data and the compute infrastructure coming all together in a synergistic manner. Deep learning revolution started with the creation of ImageNet. Thanks to Fei-Fei Li, who's professor at Stanford, for the first time, we had this large collection of labeled data that was available openly for everybody to experiment on. And once this data set became available, that's when we could realize the power and capacity of neural networks, or deep neural networks with many layers of computation. With the availability of large-scale labeled data, you could now train these large models to a high degree of accuracy. But there was a third facet that was also really crucial, and that was the compute infrastructure. In particular, NVIDIA GPUs enabled us to do this large-scale training, to be able to do lots of operations in parallel and be able to train very large-scale models. And all these three are essential to enable the deep learning revolution. And that's why I'd like to call this the trinity of AI, the data, the algorithms, and the compute infrastructure. And since the ImageNet challenge, there have been a number of impressive breakthroughs and progress of AI. But then there are also lots of settings where AI has not lived up to its hype. And that's what I'd like to focus on. What are the gaps that are there today, and how do we fix them? I think a glaring one that you'll see is when it comes to application in safety critical settings, such as self-driving. There's been a lot of hype and excitement around it, but very little progress that actually brings them onto the road in real life conditions. And the reason is because there is a long tail, right? There are just so many possible scenarios that you can't just learn all this in a data-driven manner. That is, you cannot just feed in data or examples of every scenario. You need to build something more into these deep learning AI. Another example of where AI has still fallen short is language understanding. There has been a lot of excitement over the last few years on large-scale language models. These models are able to now generate coherent sentences and paragraphs, but on the other hand, they're still a poor substitute when it comes to humans, right? If you ask them to check content like misinformation about COVID or hate speech, it's still much harder because there's so many nuances that AI does not get when it comes to language understanding. And hence, we have to think about other ingredients to build into AI that can help us really make an impact in such difficult and challenging applications. How do we get there? So for that, I'd like to peek into what are the ingredients of an AI algorithm and how is deep learning dealing with these ingredients, right? So, and especially these are important if we have to build intelligent robots. We have impressive robots like the Boston Dynamics Atlas robot that can do the backflips. But on the other hand, it's still far off when it comes to intelligence compared to our favorite animal. Even when the dog fumbles, it's able to learn new skills. It's able to interact with us. It's able to adapt. And our current robots are not able to do that. And hence, it's important to ask how to bring the mind and the body together, what I call embodied AI. And for this embodied AI, sorry, that was supposed to come together, the mind and the body coming together, what we need is to be instinctive. Humans have instinct, right? So we have priors. How do we build that into AI algorithms? They need to be deliberative, making and adaptive plans. We don't always stick with our plan, we adapt. And being able to function in a multi-agent environment, being able to understand what the other robots are doing, what the other humans are doing, that's so critical. And finally, being able to understand us and partner with us, like what dogs are able to do, we are not even able to build a fraction of that in our current robots. And these are some critical aspects to be built into embodied AI. And to do that, I'd like to emphasize on the algorithms, right? Because that's the foundations, and we need to ask, how do we fix the foundations in deep learning? And for that, the first ingredient is the data. What kind of data goes into an algorithm? And currently, when you think about deep learning algorithms, they are mostly extremely data hungry, meaning they require large data sets with supervised or labeled information. And to do this, you need humans to go and label them, and this is extremely expensive. Think about labeling images, text, speech. All this is untenable when it comes to doing this on billions or trillions of examples. And we need to get away from supervised learning. So I think that's the first ingredient to fix. On the second facet, we have the priors. The priors are additional domain knowledge you build into your algorithm. For instance, if you are operating on images, we typically use convolutional neural networks because convolution builds in translation invariance. And that's good to detect image features. But then these are still fairly weak priors, right? Meaning, if you're now doing any changes to deviate from the training data in a big way, or even in a seemingly small way, you have AI getting easily fooled. There are many examples of this. For instance, a simple way to fool AI algorithm is to add these additional boxes to an image, and it can completely misunderstand what the sign is saying. And given this brittleness, we have to ask, how do we build better neural network architectures and better ways to train these algorithms to overcome these kind of brittle behavior from our algorithms? And so then we have the third facet, which is the task. The task is what we specify the algorithm should be working on, right? So what should it be optimizing on? Should it optimize to get the correct understanding of the image? Should it understand the text? How do we give it an objective function? And finally, if it's an interactive algorithm, how does it take an action and interact with the environment? And right now, if you think about standard AI algorithms, the task specification is extremely simple. We usually have some fixed data set, right? So like the ImageNet, and a fixed challenge, optimize for accuracy on this data set. The problem of doing this is the real world can be very different from this contrived benchmark, right? It may not incorporate everything that's going to happen in the real world. And that's why self-driving is so difficult, because you cannot possibly incorporate all the scenarios in your training data. And there can also be other bad outcomes by training on limited benchmarks. For instance, face recognition has been in the news as being problematic for so many social implications. And this is because the training data and the benchmarks that are available heavily skew towards pale skin tone and the male population. And what happens is, if you're now using this in the real world, especially in sensitive scenarios like law enforcement, this can be a huge problem. We now have protests all around the country, in fact, all around the world, and Black Lives Matter is an important consideration. And you can see that AI building up biases that we see in the society and further amplifying this is a huge problem. And it stems from the aspect of having limited benchmarks that do not represent all populations equally well. And we have many cloud APIs that are publicly available that have very poor performance on minorities. For instance, in this example, Oprah Winfrey was misgendered by this cloud application. And so there is an immense need to move beyond just limited benchmarks and skewed benchmarks that don't represent the end application and the real world needs that are very important. So now what I've told you is these shortcomings that our current deep learning algorithms have. So the natural question is, how do we move from here, right? Where do we go next? And how do we fix these gaps? For each of these three facets, what can we do better? And that's where I'd like to first start with data. It always starts with data, and being able to come up with algorithms that can do unsupervised learning becomes very critical. We do a lot of unsupervised learning. In fact, infants primarily do unsupervised learning after they're born and pick up representations of the world, and then supervision comes in much later. And so how do we incorporate the aspects of being able to learn new concepts, reason about them, disentangle different variations, and be able to extrapolate to entirely new scenarios that were never provided in training data? And I think unsupervised learning is the next revolution, and that's already underway. So when it comes to priors, we need to build more robust priors, right? So for instance, we don't need to invent Newton's laws of motion all from scratch from training data. We can give it as domain knowledge to our algorithm. So in control applications, it's very important to have some aspects that are known to be embedded in the algorithm and only the rest to be learned. And these are frameworks we are pursuing and asking, how do we just incorporate data-driven approaches on parts that are unknown, but still let it function in the overall ecosystem of models and controls. And so you want to have not just one monolithic big neural network doing everything, but you have modules, and each module has different functionalities, and they have to work with one another well. And lastly, when it comes to task specification, moving away from just fixed benchmarks and one task. Can we do a variety of tasks? We call this meta learning or meta reinforcement learning. Can we be adaptive? That is, we don't just do some fixed task, we continue to learn. We humans are lifelong learners. How can we put that into our AI algorithms? So I think these are some critical ingredients to take us to the next level. Focus on unsupervised learning, make our models and algorithms more robust, incorporate domain knowledge, and be adaptive. So these, I would say, are the main takeaways that I'd like you to have from this talk. So I just want to give you one instance of how we can further get inspired from our own brains and from our own perception and cognitive systems. Human brains are so amazing, right? So there's so much flexibility we can have in terms of what we learn, how we reason, how we process, and how we do all this in real time. So human vision, if you think about it, is able to tell even what's in blurry images. If you input even a blurry cat, I can tell you, I think this is a cat. So why is this happening? And what we see is in the brain, what we have is internal models of what a cat looks like, right? And we use that to progressively de-blur this blurred out image and think it is a cat. So just as we are seeing this blurred cat in our brain, we have the feed forward and the feedback mechanisms that continuously iterate over and come to the decision, I think it's likely a cat. And how can we build this kind of mechanism into our neural network algorithms? Currently, they don't have that, right? If it's a neural network, you just have feed forward results by going through many layers, and that's it. Whereas human vision has feedback mechanisms. And in addition to that, it has priors, right? So we have internal model of what the cat looks like. And there are many theories that say our brain is Bayesian, meaning it's going to take in the additional external input from the environment, like this image. It's going to use its own priors, and at the end of the day, come up with a likely answer of what's in the image, right? So that's what perception is about. So can we be inspired by this and build similar mechanisms into our own neural networks, into the artificial neural networks? And to do this, what we set out to do is to unify the paradigms of classification and generation, right? So if I can classify that what's in the image is a cat, I should also be able to generate that this is a cat, right? So that's when you have an example of a cat that is a good example of what it looks like. So by that, what I mean is you want to have the classifier and the generator come together in one model. And they iteratively inform each other, right? So you should have consistency between the classifier and the generator. And that's what our model gives. What it does is it takes any feed-forward neural network, like the convolutional neural network, and it builds a feedback mechanism of trying to generate the image back from the label. And it does this in an iterative fashion, and then in the end, you come up with a result that is consistent. So meaning the generation and the prediction are forced to be consistent with one another. And we see that in some simple examples. For instance, you can corrupt the images in so many different ways here, right? And these were never seen during training data. And that's important to emphasize, because if these are degradations that are not available during training time, a standard neural network would just completely fail. It would have very poor accuracy. But what our model is able to do is to denoise this using the generative model and come up with better classification of what are these digits. And that's important. And that's what we see, the ability to be able to understand what's in the image and hence classify based on that. So that was an example of what is possible by building better foundations and getting inspired from our own brain. Another example I'd like to quickly show is being able to have synthetic data using physically valid simulations. Because if it comes to robotics and to build embodied AI, we cannot just keep generating data in the real world, right? That's too slow and expensive. And what NVIDIA Isaac enables is a platform for robot learning by adding in simulated data. For instance, at the NVIDIA Robotics Lab in Seattle, the goal is to build a kitchen robot that can do a whole variety of tasks. Open and close drawers, pick objects, place them, manipulate them. All these seemingly trivial tasks for us, but really hard for the robot to adapt to so many requirements. And what we do is to ask, now we can generate a whole range of different drawers and handles in simulations. And hence, we can train this at scale on NVIDIA GPUs in parallel. And if we then do all this together, we can ask how to bring that to the real world. And we are working on efficient domain adaptation algorithms that enable this transfer. So this is another example of how to get rid of dependency on real label data and instead augment that with simulated data that still have physical validity. So to conclude, I'd like to emphasize that the next revolution in AI requires generalization, and generalization beyond just the training data to entirely new scenarios that were unseen during training. And the key aspect that will enable this is unsupervised learning. We humans do a lot of unsupervised learning, and in our brain we have feedback mechanisms that enable the ability to incorporate prior knowledge about the world. And we need to bring that into our AI systems. And in addition, we need to also look at how large-scale AI frameworks will enable us to take these algorithms to fruition and to the real-world applications. Thanks a lot.
Thank you so much, Anima. That was fascinating and good to see all the work that you're doing. I personally have a background in symbolic machine learning, so it's fascinating to see what's going on here. And perhaps we can come to a discussion about hybrid models a bit later. So I'd like to introduce our next two panelists who have got amazing backgrounds and will contribute so much to the discussion. First of all, we've got Maya Pindeus, who is the CEO and co-founder of Humanizing Autonomy, a company using deep machine learning to become the standard for communication between autonomous systems and people. Welcome, Maya. And also Dr. Lisha Lee, who's the founder and CEO of Rosebud AI, a tech company that uses deep learning to create visuals of models for marketing that look indistinguishable from human models. She was previously a principal at Amplified Partners, leading investments in early stage startups, and worked in data science at Pinterest and Stitch Fix. Welcome, Lisha, as well. So I'd like to invite you both, Maya first and Lisha, to just give a bit more about your perspectives before we go into a panel discussion. So please, Maya, take the floor.
Sure. Thank you very much. I'd like to talk a bit more about one of the biggest technology challenges today of developing an AI system that is able to work across multiple physical environments, to operate around all stakeholders, people, understand their behaviors and actions, and all of that without creating mass complexities, and by making sure that systems are designed with the human experience at the core. When looking at urban mobility, a spectrum where software-enabled vehicles and systems interact with people at all times, it becomes crucial to rethink how we approach automation and think of human behavior as this universal design principle behind our automated systems. It fuels our automated systems to teach machines how to read our visual signals how to understand these signals, how to understand these behaviors across various environments. Humanizing Autonomy is a predictive AI company creating a global standard that improves the way vehicles and systems interact with people in any environment across multiple markets. Our mission is to ensure that automated systems evolve around human values and not the other way around. What this means is that we offer a horizontal, vision-based solution that captures the full range of human behaviors into a predictive system that provides real-time behavior predictions available on the edge and in the cloud, which are ideal for immediate human-machine market applications, particularly in the urban mobility context, thinking of urban infrastructure, dash cams, driver assist systems, but are also optimized for long-term autonomous system development. Our AI is based on a unique combination of behavioral psychology, statistical AI, and novel deep learning algorithms to create a multidisciplinary approach. This allows us to extract observable and inferable behaviors from video data, from vision data for intent predictions and predict the multitude of people's behaviors on the edge. We are modular. We're based on modules, software models to work together to generate fast and accurate predictions. And we're fast and flexible, meaning hardware agnostic solutions that has a small programming footprint and is applicable in real time and able to integrate across solutions today and solutions for tomorrow. Those approaches, the modularity, hardware agnostic, and the behavioral psychology approach allows us to capture this complexity of human behavior. And really, it is about enabling machines to operate around people. In an urban mobility scenario, that means 4 things, really. Increasing safety, improving decision-making, faster and more efficient progress, providing a better and smoother customer experience, and enhancing sustainability. To give a couple of examples, by allowing a vehicle to have better hazard perception, or a driver to have aided in hazard perception, we are able to reduce accidents, reduce collisions, accidents, near misses involving people, vulnerable road users. Through better decision-making, we're able to improve progress and improve the driving efficiency by a multiple. Making journeys smoother, reducing hard braking event, allowing the vehicle to really understand what is happening around the scene when driving, let's say, through central London, when driving through a crowded pedestrianized environment, and really understanding what people are about to do. Are they standing? Are they about to cross the street? Are they distracted? Are they alert? Many, many things. Ultimately, enhancing sustainability by allowing the vehicle to be more efficient, to have better decision-making, we reduce hard braking event, increase fuel efficiency. What's important is building a system that is applicable today through this hardware-agnostic approach, a small processing footprint with plug-and-play integration with various applications. Like a device helping, in the urban mobility context, a device manufacturer to deliver dashcam CCTV systems to increase fleet, passenger, pedestrian safety, help vehicle manufacturers to deliver safer, more innovative driver experiences that are also scalable to autonomous vehicles, help insurers rely on reduced risk models, and help vehicles adapt to people, and municipalities to understand behavior patterns so that cities can be planned around the citizens and not vehicles. And it's really about powering automated technology that is always able to not just look at people, understand people's actions, and determine what the best action will be to keep them safe and to keep the interaction pleasant. By doing it visually, we have adopted an ethical approach. It's important to be transparent. We're modular, which allows transparency, with a strong emphasis on personal privacy, keeping persons' data safe and well, and never track, trace, or identifies everyone. By being modular and horizontal, being able to apply this AI application to existing vehicles and systems to really help improve urban infrastructures today. We're a team of 30, multidisciplinary team of deep learning engineers, psychologists, roboticists, and commercial talent, based in London and Tokyo, and working across 3 continents. And we all came together to really build this global standard for human-machine interactions. Thank you very much.
Thank you so much, Maya. And Nisha, we'll pick up on some of the comments that Maya just made, but Nisha, if you'd like to give your perspective.
Wonderful. Thank you for having me. And Anima, I mean, thank you for painting the framework of what we can be excited about and what we should look into improving for the next kind of decade of generalized AI. To give color to one of these, which is unsupervised learning, in the area that I focus on, which is generating visuals and creative content in general, I just kind of like flesh out where I anticipate the exciting developments are and what kind of motivated me to start Rosebud. I mean, the last couple of years, we've observed such tremendous advances in quality of visuals that we can generate. In particular, for instance, one of the open source things that was put out by NVIDIA with StyleGAN generating faces. I mean, I think people in the audience might have already seen in the news really high quality headshots of a person that doesn't exist, right? And so when I saw the advancements of these results, I think there's a couple of things that was very exciting. I mean, one, the quality is getting to the point where it's high enough for commercial application, but two, to just take things straight from the research lab into application, there's kind of a lot of difficulties in making it work. First of all, you're never sort of talking to customers, so you don't know exactly how to define certain type of technical problems to give customers the amount of control that they want. So especially in an area of like, creative output, it's a very intimate kind of relationship with like, who's your user? Well, is it the designer? Is it a marketer? Is it somebody who's creating entertainment content? They want a certain degree of control. And the kind of process that you're augmenting and somewhat making more efficient is like they're back and forth with agencies, or even the agencies work with photographers and models. And so I knew that like what was exciting about this problem is that you cannot possibly only do it in isolation in a research lab. You need to help these you need to help inform the technical problem from working with customers. And then in particular, in the case of generative models and models that are supposed to reproduce, distributions of like really rich inputs such as images, there is no canonical measure of what's good, right? So in the case of, say, generative adversarial networks, you have this like game between the generator and the discriminator to sort of get better at reproducing images from people's faces, or whatever. Choose your favorite domain. In that case, because we don't have a canonical measure of what's good, it becomes even more crucial to put it in the hands of users to help you define like what does it even mean to have good quality. So in the case of Rosebud, for instance, my vision is that I think that this in the 5-year, 10-year time, a lot of our creative processes will be augmented, if not, completely, made like democratized by AI. And what I mean by democratized is really like you've elevated everyone, brands, people who need to create visuals, to the level of a creative director. They will have access to this like software in order to produce exactly what they're imagining in their head. But in order to get there, you have to start solving concrete problems. Now you have to get into the workflows and really respect both how things are done and figure out what are the low-hanging fruit to get the data input and output that actually solves people's problems. So I think one of the other topics I'm really excited to touch on is like, it doesn't have to be this black-white picture of like replacing people versus, like don't use AI, don't replace jobs. It's much more about augmenting human creativity. And that's kind of what inspires me about this area of research, and what inspires me to productize it, because I really see it as like augmenting people's ability to creatively express themselves. So even if like the first application is, say, marketing visuals, it's about like figuring out what are the sources of pain or friction, right? So right now we have the entire world is kind of suffering through like sheltering in place and not being able to have physical processes such as photo shoots. So it's a prime time to be moving and migrating to a generative process where most people can now do things with software. In my case, I'm generating novel models, like human models, and getting it to look like the demographic that people care about or represent a particular brand aesthetic. And through figuring out these problems, I can then input the technical improve the technical capabilities of these deep learning models to kind of express towards what these customers want. So yeah, kind of very excited to dive deeper into these categories. Oh, and if people wanted to check out what some of these visuals actually look like, go to rosebud.ai. So you'll have plenty of visuals to sort through and exactly what I mean by indistinguishable from human.
That's fantastic. Thank you so much, Nisha. Just great speeches from you all, and lots to think about and lots to crunch through. And I know there'll be lots of questions posed by the audience, and we'll come to those a bit later. In terms of the questions that came up for me, a couple of kind of themes come up. Is one around that AI trinity that you mentioned first up, and it struck me that a lot of people do focus on the data and the compute and the algorithms, but not everyone thinks so hard about the users or the customers or the people behind that. So I guess the general question for me is, do you think we can make the progress we want to make? And in the next 10, 20, 30 years, if we don't have everyone embedding the kind of the user within their design, the development of AI going forward. I'd like to get your thoughts on that. Maybe we start with you, Anina.
Yeah, I think you bring up a really important point, right? So democratization of AI is really critical to me, and that comes in so many ways, right? It starts with representation of all populations and demographics in our data sets, and I did bring that up in my talk, that data imbalance is a critical problem, especially if you're now launching this in the real world in socially sensitive contexts like law enforcement. And so we need to be mindful of representing the data well and having good benchmarks. I think that's the start. But another important aspect is having diversity in the AI workforce, right? So if you look at the representation of AI researchers, it's extremely skewed. I mean, there are a lot of amazing female AI researchers, and we have affinity groups like Black in AI, Latinx in AI, queer in AI, but we don't see them always represented in the same light, in the mainstream media. And that's something I emphasize a lot on, to bring more diverse thoughts into AI, and that's how we can grow and put that to the next level. In fact, the gender state study that brought up the issue of face recognition being biased against minorities was by a Black researcher in MIT. So we have to have this diversity in our schools, in our AI companies, and that's something we should strive for. And finally, I think indeed, even if it's not AI experts, right, everybody else who uses these AI systems and the interfaces, we have to ensure that we take their input. For instance, if Alexa works only on certain accents and does not recognize my mom to the same extent it recognizes me, it's a big problem. Right? So we have to ensure that there is good quality of service available to everyone and their inputs are taken.
Absolutely. Thank you, Maya. Alicia, Maya, perhaps you first.
Sure. Yeah. I think it also comes to really take into account a multitude of environments. When I think of the area we operate in, where we work in cities, automated system operating through dense urban environments, to make sure that data sets are collected from a representation of the real world, meaning not only Silicon Valley, but European, Asian, African cities, where to be able to really take this kind of whole multitudes and actively create this equal representation, but also take into account edge cases, take into account different things that people do and people's actions, make sure that those are also included in data sets. And if during training we're recognizing that more needs to be included, more needs to be added, be transparent as well, and kind of recognize where the system requires more data and more of these peculiar situations.
That's really helpful. Thank you. Nisha, did you have perspective on this?
Yeah, when you guys were talking about it, what came to mind is a specific example on how basically when people sort of think about, okay, if you can create faces, like what, maybe that obviously just perpetuates very unrealistic beauty standards. And what's interesting to me about that response is actually, this is why it's so important that, I kind of sit in the front seat in helping productize and develop tech in this area. Because really, if my users are very diverse, that actually helps, and I make the tool that more allows more people to create visuals. I've actually introduced more diversity in the voices of like what are beauty standards there. So actually a bunch of my users are Gen Z, say fashion designers, and they have very non-standard beauty sort of like aesthetics that they want to represent with their brands, and that's kind of what I'm excited in seeding. So yes, of course, if you have standard, very classical beauty standards, you can express this with a tool as well. But it's really in like how you're trying to motivate and distribute this platform and expressive tool.
Thank you. That's really helpful, and I'm sure there'll be a lot more questions on this. I think we've got 5 minutes left, and one of the questions I wanted to ask was kind of on the technical side as well. I mean, you mentioned kind of the push towards unsupervised learning. I think for me that raises questions around explainability. Is that important? Is that helped or hindered by going further down that route? And also that you mentioned the Bayesian approach. I wondered whether you see there's room for hybrid approaches, because I think from what you're saying, deep learning does have limitations, but again, that's where a lot of the focus is and has been for a number of years. Do you see the possibility or the need to even look at other approaches, or to kind of develop hybrid approaches at any of this? Or do you think actually a lot of the tasks we want to look at, deep learning is going to be the way to go?
Yeah, that's a great question, right? And to me, as a researcher, I'm always curious to understand different aspects and different approaches, and also ask how they can work together, right? Because I think the answer in the end will be some kind of hybrid systems. Deep learning is great when it comes to learning in a non-parametric way with lots of data available, right? You can have now a flexible model. You don't have to make a lot of assumptions, and complex data like images, you can extract the features. So that part is important. But when it comes to, let's say, explainability, you say that you uncovered a concept called the chair, right? Then you should be able to generalize to new chairs that you didn't see in training data, but still there is a concept called chair. And there I think we'll have like neurosymbolic systems, which are hybrid. So AI classically was all symbolic, right? It was based on logic. How do you kind of operate on different concepts, right? And what kind of inference do you make? And so I think some of that is coming back. And the question is, how do you scale that and put that in conjunction with deep learning? And I think that also enables us to provide us with modularity. So it's not one monolithic big neural network, but you have parts, and each part has its functionality, and it can talk to one another. Just as we don't build a huge aircraft all from scratch, end to end with data, we have to build parts, and we have to make sure that each part is well tested and put together. And that's where I think neurosymbolic systems will play a role. I think with Bayesian inference, there are interesting questions of how to bring in prior knowledge, right? And that's what I emphasized in my talk, that brain has all these internal models. Can we also bring that frameworks into our deep learning systems, and and of course combine it with also data-driven training, right? So it's not, I think there won't be one answer, it'll be a combination of answers.
That's great. I guess the final question I'd like to pose in kind of closing minute or two, I guess maybe us for 20, 30 seconds from each of you, is around how it's best to engage the public, the users, the customers, given all the change that's likely to happen in the next 10, 20 years. What is it that the AI community should be doing to communicate the art of the possible, and what might be coming up to people outside the community? I don't know if you've got any thoughts on that. Perhaps, Nisha, we could start with you.
Yeah, sure. I mean, especially in the area that I'm working in, there's a lot of very obvious negative use cases. I mean, deep fake and propaganda is like the first ones that come to mind. We have a code of ethics that kind of, we started it early on because it was really important for us in a position of knowledge to just make it clear that we're going to share our understanding of where the tech is going and kind of make it a responsibility to educate the public. And I think that's for anybody who's like working in the area from a research perspective or a product perspective, that's the first thing that they can do. And especially since given how kind of democratized this platform is of sharing. You know, we're not sort of like only beholden to the media in order to communicate one-on-one. That's where we've at least been able to take action. So yeah, just kind of sharing like what are the capabilities so people know at least what's out there, so nobody's guessing.
That's great. Thank you, Maya. Do you have any thoughts?
Sure, it's great to hear, Alicia. You know, about the code of ethics, and I think ethics is really, you know, one of the most important things to kind of bring out to the public, and you know, how data is treated, how AI can be, you know, explainable, how it can be transparent, how it's not all about data-driven end-to-end systems, but I think the modularity comes into play. But also thinking about user experience, and user experience not just as the person who purchases a service or device or whatever it may be, but the public as a user, really, because that's what you know happens with AI. Really, we all become users, and if we all, you know, AI is designed with us people in the loop. And I think step-by-step introductions to automated systems and really educating the public around what this means and the opportunities that this become. I think that will be, you know, helpful steps.
That's great. Thank you. Anyway, have you got any final comments on how we can best engage to make sure that we adopt in the right way?
Yeah, I think as AI scientists, we have a responsibility to give honest and balanced feedback on the different systems that are in, you know, are getting popular, right? And especially with deep learning. So I have called out in the past when I think it's hyped up and not realistic, especially with language understanding models that, you know, that are impressive but still far from replacing humans. And also tackling misinformation around AI, I think, is critical. You know, the Sophia, I call it the fake bot, because, you know, it's almost a dystopian world we are in, where, you know, there are no female speakers represented in some of the conferences, and then we have the Sophia front and center, right? And it even appeared on the Cosmopolitan magazine. I mean, no female AI researchers has ever appeared on that magazine. And so we have a huge problem there when we have feminized bots being represented, whether it's Sophia, whether it's all the voice assistants, and instead we have bad representation when it comes to AI researchers. I think we need to fix that.
I think that's a great point to end on. So thank you so much. Thank you to Anima, to Alicia, and to Maya. Fantastic contributions. Lots to think about. I'm sure we'll get lots of questions to answer after the break. At this point, I'd like to hand back to Anushka.
Thank you. Thank you so much, Zoe. What a fantastic conversation. And for anyone who's watching, you can click through from 7 p.m. to the Q&A session. Make sure you get your questions into the panel. There was so much to cover. I mean, generalized AI in the next decade. In AI, there is still so much to do. So we'd love your questions to come through. This is the Cutting Edge stage. My name is Anushka. I've been your host since the morning, since 10 a.m. We've taken you through all of the proceedings today. Today, we've covered everything from giving AI a human face to implementing how to implement AI as a smart co-worker. And we've looked at and dived into the interplay of AI and the collective intelligence. We've discussed collaboration across research and community with Facebook AI. One of my particular favorites, and I can't be biased because every session has been fantastic, was the conversation and panel on empathetic AI. And to round off with sort of like the next decade in AI has been full of lots of insights that we have yet to build on. And yet this is only day one of a 3-day festival. For the first time in its 4-year history, CogX has gone completely virtual in light of the current pandemic. So there are 2 more full days of content here on the Cutting Edge stage. So I'm going to wrap up formal proceedings of content here on the Cutting Edge stage. We'll be back live tomorrow from 10 a.m. My colleague Gemma Milne will be taking over. I will be chairing a panel on the planet stage, and we'll be looking at space data And I look forward to welcoming you to the programming on the Planet Stage tomorrow. So this is me, Nush, signing off from the Cutting Edge stage today. Thank you for joining us. Keep the conversation flowing on Twitter with that hashtag CogX2020. And if you'd like to follow the links through to the breakout room, please continue the conversation with questions for our panelists from our last session. Thank you so much.